In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the
All right, hello and welcome, lads and ladettes. We're about to get into it here.
Within range to be able to replicate without, anything too dramatically expensive or specialized. So that's what's really awesome about it too. So, if this was replicated, 100 more times, 200 more times in total, and documented really well, that would be amazing.
Yeah, and I just want to say, I will beat anybody's price on a CT, or your CT is free.
Hey, well, are we talking where to buy a celestial theodolite?
Yeah.
Funny story, lads. Turns out you build celestial theodolites, and that's what we're going to learn how to do. We're going to go over the methodology and the measurement here. We're going to talk its significance. I'm going to try and get through it as quickly as possible because I want Ruhif to be able to chime in here. Ru, how much time you got, buddy? You got like 45 minutes? Oh, wait, I can't hear you. Hold on.
Would only go for 15, but I'll try and listen in anyway.
You said 15 minutes.
It's got 50. It's like 15 minutes total.
Oh, well, in half an hour, I should be available. We'll see.
Oh, okay, yeah. So you can come back to it then. Okay, no worries. Yeah. All right then. Okay, so guys, where do I buy a celestial theodolite? Does anyone know? Anyone know where to get one? Is it Walmart? Amazon?
I got mine on Amazon.
I think I got offered one in an alley one time.
Someone here mentioned Toys R Us. I was going to ask for the link if.
Yeah, you can get a coupon online for one at Toys R Us.
Yeah, that one was time dilated back to the 80s though. Anyway.
All right, let's tune in.
All right, lads. So to give an overview now, I think everyone on the globe side would agree that this should be replicated in other locations at different distances with different stars, etc., so that we can establish whether or not this is a once in a lifetime localized, one in a godzillion, trillion, billion phenomenon that just happens at this one particular location, or if this is something that can be replicated for everyone and showing that the implication is, geometrically speaking, that the Earth is flat. So how does one go about obtaining a celestial theodolite? So you start with a couple of things here. It's a little process. We got a checklist for you and some resources to use to gather the necessary information so that you can input the information yourself and figure out what stars that you will be being occluded by objects near you, and so that you can make your own measurements and when they'll be occluded. So we're going to use Mike's example to start us off with because he already gave us all the hard part. But I'll walk you through what it looks like to do the hard part anyway. But anyway, to start us off, we're going to have our observer latitude, longitude coordinates. So that you can get that, however, GPS coordinates, an app on your phone, etc. You can look it up. Doesn't matter. As long as you know where your lat long is, where you're making your observation. Then you have your mountain peak or whatever physical obstruction that you're going to be using. I recently tried to use a building obstruction, but I don't think that's going to work out or be significant. I don't think anyone would takes significance on that. I think the mountain peak measurements give a better angle and better discrepancy between flat and globe predictions so far. So we'll stick with mountain peak. But anyway, you need the coordinates there. So when you're using a mountain peak, when you look them up on Wikipedia, usually the coordinates go directly to the highest peak point. So you can use that for reference. And then there'll be a secondary website you can use to get your elevation using latitude and longitude. It'll get you the GPS elevation relative to those points. And that's all the information that you're going to need. So this website here called movabletype.co.uk, copy link. You're going to take your observer observation latitude, longitude. You're going to enter this in first for your point. Now, this is for the building thing that I was looking into, I think. So this isn't, actually, this is for something else. But anyway, you enter your point here for point 1. Then you enter your peak here for point 2. Now, it's important you enter it in that order because that's going to output you a final bearing, which will be relevant for your hunt later when you try to track down a star to see what stars you have available to make your measurements with. And also, in addition to that, it's going to give you the distance. And it goes over various ways that it derives the distance. You got your haversine, you got your midpoints, all kinds of different arc chords, chord lengths, etc. It does them all, right? You can, it's accurate. It gives you what you're looking for, right? It gives you that nice globe distance, right? I saw a haversine in there. Is the globe hiding in there? Is there a globe in there? Anyway. Or are you just deriving a distance on a spherical coordinate system? Anyway, who knows? So what when you have this information, right, the distance and the final bearing, you're going to take that over, you're going to save all that, write it down. And then the next thing you're going to need is once you have your elevations, you can take the difference of those. Okay, so we should be able to move on now. Okay, so now that you have the necessary information, you're going to find a westward facing peak because you're going to be looking for stars that are going down into the, setting into the mountain, right? That are going to be occluded by it. Otherwise, you'll be doing star rises, which you could do, but it'll be significantly harder. So you're going to make sure that you have that, and then once you have all that, you hit up your boy spreadsheet over here. And okay, so if you notice so far, we have a distance for 2 locations and elevations for 2 points, right? So observation point elevation and mountain peak elevation. We have a distance. Now you can come here and enter all the necessary information that we gathered so far. So using Mike's example for Pikes Peak, we take the 4,300 meters. We take, and then the elevation for 50.7 kilometers away is 2,074 meters. And the difference of that is going to give us 2,226 meters. And that's going to be what we're going to use to complete our triangle to get our angle prediction here for what the angle relationship would be for a star to be intersected at if you were to go here with that same angle with respect to that distance that you're deriving the angle to. So we come out with, based on these values, the distance away from the mountain peak and the mountain peak elevation difference, we get 2 degrees, 31 arc minutes for the raw calculation for what it would be. And then we have, over here on the other side, we have the globe predictions. Now there's 2 ways that you could get to the globe prediction. You could use the arc sine of the distance over the radius, and that will give you 2 degrees and 4 arc minutes. And then you could apply celestial refraction to get 2 degrees and 19 arc minutes, which is what the glob predicts. Or you could do the method that Ruhif uses, and then you apply 2 arc minutes for terrestrial refraction. And then when you get to the mountain peak, you would then add your celestial refraction because you're making the celestial observation. So you add the 15 arc minutes. But either way we get here, the values are the same. And this will be important later when we go over how the globe difference only exists in these refraction corrections, because the timing of which this star is going to get occluded is going to correspond to the flat Earth angle, which is going to be extremely significant here moving forward. But if you notice, all we have here is our angle prediction so far and the distance to these locations. Now what we're going to do with this information is we're going to go to Stellarium. We're going to input the coordinates for the peak. So we're going to type, I already have it saved for us for convenience. So we type peak. It's going to take us over to Pikes Peak here. And then we're going to look up this star at this specific time. Now we happen to know the time because that's what Mike already did the long process for and found when it would intersect at this point just by letting the night sky play out. And then when you have a star at this point in your screen, once you have everything aligned with your grid here for 2 degrees and 30 arc minutes and that final bearing that we got earlier when we calculated the distance, we can look up at this angle right here and play out the night sky for different days and see when a star will appear here. Now, the star that appeared here was 39 Aquarii at this specific time. on the 31st of January at 6:27:25 p.m. Mountain Time. So what we can do now that we're on the top of the mountain peak, remember when we're at the mountain peak, we haven't entered the distance. Stellarium doesn't know where we're making the observation from. All Stellarium knows is that we're at this mountain peak and we're looking for this star with refraction turned off. So when refraction is turned off, it defaults to the nautical almanac position, which is its quote unquote true position at this location and time. And then when you turn refraction on, you get 2 degrees, 47 arc minutes. It fluctuates a little bit. It was 46 earlier. That's weird. But anyway, and actually when you apply the proper M-bar correction, it goes down a little bit because of a problem with Stellarium or whatever. But that's only significant for the globe prediction, which isn't the timing for that isn't even going to be manifested. So it's largely irrelevant to, but anyway, that is what that value comes out to be. Now, we have this time here for this. The star is going to be here at this time, at this angle. Okay. Now, remember, we calculated everything we calculated this angle based off of what the elevation angle of this mountain peak would be based on us being 50.7 kilometers away. So if we're 50.7 kilometers away and we're looking up at 2 degrees and 31 arc minutes, and we're filming a star, we're taking a time lapse, and we see this star coming down, and it gets occluded. And then suddenly we can't see it anymore, right? We don't care where it's at or where it was, etc. Right? We can see it at a certain point, at a certain time, and then suddenly we can't see it anymore. And if that time that we can't see it on the ground corresponds to this time that was predicted at this angle, I'm sorry, for this angle to be at this time, then that geometric relationship only works out if the Earth is flat. Now, the reason for that is because the globe Earth, right, relative to your position, predicts that the object is going to be tilted away from you due to 8 inches per mile squared with a ball of a radius of 3959, right? So when you take off the 200 meters of that elevation peak, that's going to be the difference where they physically predict that peak will be to intersect the star. So if the star's true position doesn't intersect at that time, which would be later than the time that was measured, so the time of 6 p.m., 27 minutes, 25 seconds, right? It would take more time because the star has to get lower for it to be physically occluded by this globe slant at this position, because Stellarium doesn't know where we're at. So that's the only reason that this would work on the globe, is if it actually got occluded at the globe time, because you have two different predictions for the elevation of that star with respect to your refraction corrections. So you apply refraction here to get 219, whether or not you do the celestial refraction correction or you use Rehif's method, where you do a 2 pi situation and you get 2 degrees and like 14 something or 15, or no, I'm sorry, 217, you get 217 arc minutes. Then you add 2 degrees for terrestrial refraction. Either way you slice it, we've refracted and put this physical measurement here. This is based on what globe predicts from measurements taken during the day, right? So that star has to physically be blocked at that exact time. Otherwise, it's not physically there. So that's the significance of that. All right. Does anyone have any questions before we get into refutations or anything like that? Does anyone have any questions about this list?
I have one. What is the logic behind removing refraction from the flat Earth prediction? Because I mean, refraction exists, so if the flat Earth prediction is an accurate model, it shouldn't account for refraction.
If something isn't visible, is it refracted?
I mean, refraction is just the bending of light.
And would it be fair to say that if the light is no longer visible, that it's at some point, due to some reason, it's finally being physically obstructed by an object, and by which a point where refraction can't overcome the angle disparity between the source and the object? Is that fair? Like at some point, you're going to be able to block something, right, physically.
Well, here's the thing. If you think about it like this, and you said you didn't want to get into refutations. I just wanted to know the logic behind it. I didn't want to actually begin a refutation yet.
Well, this is the logic behind it, because
Okay.
if you agree that you can have something physically obstruct something, and then at a certain point when you can no longer see it, if you agree that, yeah, it's not being refracted anymore because I can't see it anymore, then that is the logic behind using the raw flat Earth elevation angle prediction, because all we did was calculate the angle based off of the distance and the elevation difference, right? We didn't measure anything, right? We just calculated the raw what it would be.
Okay. Now, I would disagree, but sorry, my dog is an idiot. I would disagree, but would you want me to do so when refutations start, or do you want me to state now?
Oh, you can feel free, fire away. Fire
Okay.
well.
Let's imagine a scenario where the Earth is flat, okay, and you're looking through your theodolite and waiting to see when the star would be occluded by the peak. Okay.
With you
Now,
so far?
freeze the moment right there.
Okay.
Okay. And now imagine a change in refraction. It would be possible for refraction to change in such a way that you could then see the star.
Okay. So
It's not about seeing the star, though. It's about when it's not seen.
thank you, Beast.
Well, that's the point. Because if you can have different values of refraction even on a flat Earth and have different times at which the star could be occluded, that's the issue I have with the entire system.
So are you
but-
suggesting then that perhaps when this observation was made and the star got occluded, that it could have like there could be a time when it gets like refracted back up and you could see it again, then that would invalidate it?
I'm saying that based on the amount of refraction, the star could be occluded at different times.
Okay.
So that right there means that there's a conflating variable that's not being accounted for on the flat Earth model.
Hold on. Let's get you to agree that that is what the globe Earth predicts. That angle, 2 degrees 46 arc minutes. With
I haven't
refraction
done I haven't done the math, but I'll take your word on it.
Okay, well then
Yeah, my whole reason for being here is I'm just trying to see if I can better understand the process being followed. Because I've been going through different documents trying to figure out how the celestial theodolite works so that I can better understand the mechanics of it. I think I do now. Thank you for the description you gave. So that's the reason that I'm sitting here thinking about these kinds of scenarios.
What kind of scenario are you describing? Because I asked you what you're trying to say. Are you saying that so it gets occluded at different times, yet the time corresponds specifically to its true position, where you don't even think that that's where it's at, that at the same time that it intersects with a physical calculation of what an elevation is based off of the difference between the elevations of two points. So,
well, like I said, I'm trying.
And then this was
to,
hold on. And this was
Sorry.
repeated with other stars, not only at this location, but at another location at 30.9 kilometers or 35.9 kilometers. So
yeah,
the idea
right
that
now I'm not worrying. Right now I'm not worrying about replication. And the reason I say that is if there is a conflating variable that is not being accounted for, then whatever is causing the results you're seeing, given that conflating variable, could also be impacting the other ones.
So you're just appealing to an unknown variable that may or may not be affecting.
I'm not
the
appealing
angle?
to anything right now.
Yeah.
Okay,
All
so
right.
why
Okay.
you-
All right. No, you're good. You're good. It's all good. So we're gonna discontinue this line of reasoning. Thank you for your questions.
Yo, I think what might help is how long is your theodolite? How long is your celestial theodolite, Alan? Like how big is it, do you think?
See, that's the other component of it too, right? At the timing, if those timings intersect, then, and I'm using the mountain as my crosshair, then my theodolite is 50.7 kilometers long. So the only way that it gets occluded at that time anyway, right? The only reason that matches anyway to begin with is because the flat Earth prediction is where it's physically putting that mountain peak with respect to the elevation angle of that star at that time, because Stellarium doesn't know where we did Mike's observation from. It doesn't know how to backwards engineer what to put it in the right spot. That's the significant.
Exactly.
That's why this triangle
Exactly.
works out. That's why when you guys move, and I don't mean, and I'm not speaking for you because I don't think I don't know how. Anyway, when people try to argue this and they move the observer to Mike's house and do the calculation for where the star is, and they say, "Well, it's in this position. That's where the
Stellarium
globe
says
predicts."
2 degrees
That's
6 arc minutes.
that's because the globe is doing 69 miles per degree, and changing all of that for the thing that doesn't matter. What matters is the timing that was measured that it actually got occluded. The only way that that's physically possible is if geometrically if this is parallel, if these two lines are parallel, basically at this elevation. That's the only way.
Yeah.
And because the Stellarium only knows the middle point, doesn't know the point to the right. So trying to account for refraction, or maybe if as a variable, as whatever, from the observer to the mountain is negated because we have a 50.7 kilometer theodolite starting at that mountain. So if anything, you can only use half of that refraction, and we can argue that.
So why doesn't Stellarium predict everything? All of the angles that Stellarium predicts for this particular point in time, why aren't they all correct?
Because it's not about Stellarium from Mike's house. Like if you went to Mike's house and put the observer there and then try to look at the star, you wouldn't be able to see it anyway because that's not the point.
Yeah, it would be different for both lads. Like it's not the application of what's being put forward in terms of how we're deriving the significance of the triangle that's being made with it.
Yeah, we don't have to throw out Stellarium. You guys want to for some reason.
But you're throwing out half of
we don't.
Stellarium, now, aren't you?
No,
we don't.
No, listen, Stellarium agrees with the way that we're using it. And the reason it doesn't agree with the way that you need it to, even for where the measurement was taking place, is because the Earth is flat. Stellarium doesn't know where Mike's house is. These distances could have been anything. It's relative to the angle that you derive at that distance. That's what this shows. And that only works if it's a flat baseline all the way through. So when you misapply it and go to Mike's house and look at where it's at, it's going to tell you where different things that contradict it. And you're going to be like, well, who's right? Well, how are you using it? You got to understand, Stellarium never knew where we were at when we made the measurement, and it intersected at the same time. That's geometrically impossible on a globe. That's why everyone is now agreeing that the timing is fine, but they're trying to change the angle relationship to be at Mike's house and say that, well, it's here, but it's not at the mountain peak. You guys are doing the inverse argument.
Yeah, so far the only refutations have said, what if, and why is Stellarium wrong?
You guys need a different timing, geometrically speaking. Because if you're refracting here, right, we're not refracting here, we're not refracting here, right? We're consistent with our measurement. What's happening here, we refracted to get up to 219 to put this peak at this elevation angle to create this, to be intersected here at a time that's different from our prediction. So the globe, what happened here isn't even on the table. Right? I don't think
I guess for me, Alan, the key thing is you only have one measurement and one calculation from Stellarium, right? So if you took a measurement from Pike's Peak and one from the house, then that would be more consistent to me.
No, that's what you need. You need that to calculate refraction.
And it also, that makes different predictions for the observer location. Remember, my theodolite crosshair is the mountain peak. My eyepiece is my eyes. My crosshair is 50.7 kilometers away from me. So geometrically, this would only align. My theodolite could only work, right, is if this baseline here is flat. So when you say, we could have two people confirm it, nope. That's not the issue at all. What we already did is we used an entirely separate mountain and distance and confirmed the same relationship. I turned my theodolite over to another mountain 35.9 miles away and did the same thing. So the proper use of the celestial theodolite and showing the angle relationship with the timing geometrically corresponding to these flat Earth angles is perfectly fine for me, boys. I'm good. You guys are missing a timing and angle.
Yeah, but you're
That's
also
just
missing
incorrect.
the measurement of the second angle, right?
Nope.
That's Alan.
I've got a full triangle here, my dude. See, you see this right here on the screen share? This triangle is completed because the star got blocked here, and we know it got blocked here because we observed it here 50.7 kilometers away. So my measurement is actually complete because I started with a prediction here on Stellarium, and I confirmed it from a location that Stellarium had no idea where I was going to be at. So my triangle's good. Your triangle over here, 219, which is anyone quit real quick, hands up. Anyone disagree that the globe predicts that the elevation angle of the peak is 2 degrees and 19 arc minutes? Anyone
Good
disagree?
question.
Correct. And the star gets occluded at 219. The measurement was 218.
Rue, your mic is like coming in horrible.
Your mic.
Is it?
Mic. Okay.
Yeah, it's so loud.
Now, at 219, when it gets occluded for the guy on here, according to globularity, right? If you're on the peak at Stellarium, right? If you're on the peak at Stellarium, you're gonna with your refraction correction on, you're gonna be at 246. So you have two different predictions here that aren't manifested, whereas mine is only works if the timing is the same with respect to this angle to the if the angle to the star to the peak match the angle to the peak to the observer. That's the only way my timing works.
Public's peak to check the value.
No, just lower it a lot.
Hang on.
Yeah, your boost is like your gain. Sorry, your gain is like really high.
Hang on. Hold on. Voice and video. Okay, I'll turn that. Is that better? A bit better?
Mm-hmm.
Yeah, it's a bit better.
All right.
Yeah.
No one's on the peak to verify that number from Stellarium, right? But you're claiming this is not predicted by the globe. Is that correct?
Ooh, are you disagreeing with the Nautical Almanac? You don't think that so when Stellarium says that it's at 231 at the peak here when we're looking at it,
we're not on the peak.
Yeah, we are. My Theodolite crosshair is on the peak. Yeah, it is. That's what's blocking.
Globe,
that's what blocking
the globe prediction. What is the globe prediction from Mike's house? 219, right?
219.
From Mike's house to the peak.
From his house.
For the elevation
from Mike's house
to the peak.
Yep. 219. And what is Stellarium's prediction from his house to the star at that time?
206.
206.
219.
John just told us.
No, 219.
Is that with or without refraction?
Of course, it includes refraction.
Okay, John.
We have an atmosphere.
He might have given me the not correct. But anyway.
Right.
But anyway,
so the globe prediction. The globe prediction for the mountain is 219. The Stellarium prediction for the star is 219, and it was measured by Mike at 218.
Ooh,
how does that contradict the globe?
Ooh, really bad, because here we are on Stellarium at the mountain peak at 231. Listen, guy, we're at 231 on the mountain peak. This is where the star is at, right?
I don't care.
Now, no, listen, I know you don't care, but this is why it's significant, and this is why you keep deflecting. So here we are at the peak, 231 for the physical location in agreement with the Nautical Almanac as derived by flat Earth elevation angles, which we're going to show here by saying that in order for this angle relationship, which we derived based off of an angle being from an observer 50.7 kilometers away from this mountain peak, in order for these two to intersect at the same exact time, right, for the physical location, for this to work out, the timing would have to match. And guess what, Ruhif? It matches here. It doesn't match at the time that puts the star at 2 degrees and whatever you said, 2 degrees and 19.
Okay. The globe prediction does not do stupid shit. Hang on. The globe prediction does not do stupid shit like put the observer somewhere where he's not. So the globe prediction, 219 for the mountain, 219 for the star, and it was measured by Mike at 218, which is pretty close.
Number one.
It does not contradict the globe.
Number one, your gain is still affected. It's still messed up. So maybe you might hold on one second. Sorry. You might be too close. Number two, when you say it doesn't do stupid shit like that, that's not stupid shit. This is a meticulous process and prediction showing that the elevation angle derived using just plain trigonometry corresponds to the true position of the star in the sky at this specific time to be intersected to complete this angle relationship for refraction to not be affecting it anymore because we can no longer see the star. Now, you said that Stellarium doesn't do stupid shit like move the observer where he isn't. Okay. Now, I told you my Theodolite is 50.7 kilometers long. I'm using the mountain peak as my crosshair. Okay. The measurement timing would only correspond. My Theodolite could only work if that true position was represented by a flat baseline. So when you have the observer at different locations, right? If you want to play that game, right? When you go to the peak, you predict the star is in a different spot. Because here we are at the peak, 246 with refraction on. So it can't be in different locations if this elevation peak is intersecting with it on a globe, dog. You don't have a timing. You're trying to take my timing.
The very simple questions are: is the globe prediction to the mountain from his house? Is that prediction 2 degrees 19 minutes? Yes or no?
Yeah.
Yes. Okay. Is the predicted star occlusion time from his house at that time? Is that angle 2 degrees 19 minutes from his house?
No.
Yes. And did he measure 218, which is very, very close?
No. It got occluded at 231.
Hang on. Did you say yes or no?
No. I said no to the occlusion timing. It got occluded at the time that corresponds to 2 degrees and 31 arc minutes because that's the angle. No.
According to Stellarium.
Yes.
Stellarium.
So are you throwing out
according to
Stellarium?
the Nautical Almanac, are you throwing out the Nautical Almanac in Stellarium? Because we're
at that time from his house, it's 219.
We're not going from his house. You keep moving it back to his
house.
Listen,
I'm not doing stupid shit like moving the observer to somewhere where the observer's not on a globe.
That's exactly what you're
doing. Dude, this guy.
That's exactly what you're doing.
He is.
Dude, stop.
I'm putting the observer where he is and asking Stellarium at what angle is that star at that time. And I do that and I get 219, correct? Or 218 and a half.
Purposely refusing to engage with it and only beating up a strawman, or is it by accident?
Ruhif, when you put the observer on the peak where we're using our Theodolite, where we derived our prediction, where we derived the physical prediction, what does it say? That's where the contradiction at. Yes. That's where you need to be concerned because the only way this triangle works is if the Earth is flat. So you need to directly be concerned with this. I'm not concerned with why it doesn't match up on the globe, dog. You're a globe earther. You need a different timing. Your timing doesn't correspond to the true position of the star. Only with refraction to get up here to make a flat Earth prediction. So this is the significance of what I was talking about earlier to keep in mind for this celestial refraction versus the terrestrial refraction. So Ruhif here, terrestrial refracts to 219 to put his physical observation here to make it here, right? Now, when you add the 15 arc minutes that you're supposed to for this peak, it puts it above it. So you have conflicting intersection times. You can't have, yes, you do, because you're not dude.
Do you want me to show you a screenshot from Stellarium saying that the star is at 218 and a half?
Yeah, where's your observer? Where's your observer?
At his fucking house where he's observing.
Okay,
idiot.
so you're not making it analogous. So
I understand. Listen, I understand what you guys are doing. I think what you guys are doing is rubbish. Stellarium gives you the angle.
Dude, fix your mic.
Where you are.
Your mountain couldn't physically occlude it there at that time, but the true true position of the star is at 2 degrees and 31 arc minutes. That is what is occluding it at that angle. Sorry, dude. Yes.
I posted 2 slides in the chat. All right, this is what's happening. At 6:27 at 25, the curved path of the light is going over the top of the mountain. 6:27:26, that curved path gets blocked by the mountain. You're still looking at the same angle from.
You're being so disingenuous right now, bro.
Fuck off, please, you stupid cunt.
Yeah, see?
Dude,
you hear this guy?
Every time you get like that, like it's That's
and it's
not
because he's trying to basically put it into a straw man argument. He's arguing
No,
against an argument that
you're
we're not
trying to straw
making.
man the
Yep,
globe
exactly.
and calling me
no,
dishonest, right? Which is why I called you a stupid cunt.
no,
So really
no,
hard
no.
up.
Listen. Stop trying to invoke emotional reaction out of everyone to derail
Well,
this.
then don't call me dishonest, and
Keep it.
I won't do that. Okay.
All right,
Okay,
oops,
then
dude.
prove
Listen,
your honesty right now.
Ruhif.
Why are you putting the observer back at Mike's house when that's not the analogous way to do it?
Right, because I'm talking about what the globe predicts. All right. The globe.
Okay, what is the globe?
Normal people.
Okay, can I ask you a question? Can I ask you a question? What
Sure.
does the globe predict for an observer on top of the mountain looking at the star? Be honest.
247 or something like that.
Okay. Thank you.
Cool. So you won't call me dishonest again?
No, but why are you moving back the observer back to Mike's house? When
Listen.
Why do you think I'm putting the observer
You could do it. You could do it anywhere. It doesn't even have to be at that distance.
Do you have to put in
Do you,
the observer location?
Do you understand
Stellarium,
that?
yes or no? I understand.
And where do we put our observer location at?
Yeah, on Pikes Peak, where he
Okay. Thank you.
Where he is, or I mean, where the Theodolite is. I'm sorry, where the Theodolite get? Yes, my Theodolite is the mountain peak, bro.
No, it's not.
Yeah.
Again, we had this discussion the other day.
No.
You are claiming it's a straight line between his house and the mountain peak.
Are you claiming?
Then you say, yes, we agree refraction's everything.
Do you look at this triangle, bro? The only way that the timing of this gets occluded, the only way this works, right, is if this star isn't being refracted anymore and we can't see it down here. Yeah, so that's not the issue, right? That's why my Theodolite is 50.7 kilometers long. That's why it could be any distance that I derive the relative angle to. That's why this is
line.
Anywhere you do this, that's why it works, bro. Quit trying to straight line me. That's so weird. Are you arguing against a triangle?
Yes. Are there straight lines? Are there lights on the visitor center?
Oh, I don't argue with people that don't know how triangles work, dog.
I guarantee you I know how triangles work. Are there lights on the visitor center? Yes or no?
Is there a triangle completed from the raw elevation angle of the star with respect to the Pikes Peak that corresponds to a time that was measured 50.7 kilometers away, showing the exact same angle, showing that the physical intersection point of that star was at 2 degrees and 31 arc minutes?
I agree. You've drawn a triangle with straight lines. Are there lights on the visitor center? Yes or no?
Does the time of those straight lines correspond to the time that the measurement was made? One second.
And you're reflecting from mine.
Now, 1 second. We just have one more question to complete our triangle, though, because our triangle is completed by time. So does the time at intersection match the time that Mike measured it from his house? Yes or no?
Did the star get occluded at 6:25:27 or whatever? Yes.
Okay, thank you.
Yeah.
So geometric. Okay, yeah.
From the visitor center.
Sure.
He doesn't want to, dude. Why are we playing fuck around with Ruhif right now, dude?
Well, hold on.
I want to ask a question when you guys get a chance. I want to ask a question.
Yeah, I got you.
Me too.
Is
the light coming from the visitor center refracted?
Between you and the thing, yeah, sure, because you're seeing it, yeah.
It's not a straight line.
If you put if you could no longer see it because it was blocked, then it wouldn't be refracted, would it, Ruhif? That's the point. So why are you doing that? Exactly, because that's why we're not accounting for refraction, because we can no longer see the object. If you can see the thing, that's what's in contention here.
Okay, so let's say you're looking at the visitor center lights, and it's refracted, and then someone turns the light out. What happens?
What?
Does it change? Does
Dude.
it change elevation?
The fuck are we talking about, Ruhif?
Oh my god, bro! If that's not even analogous, we're talking about a moving thing that's not even connected to it that gets intersected by it, dude. You're talking about a thing that's on the thing that's in question. That's Ruhif. You're a grown adult. Come on.
Yeah.
Yeah, can we make room for people who actually want to have a back and forth?
Yeah,
because
sorry.
he obviously is misunderstanding the argument.
Sorry.
I got one question. Can I ask a question?
Go ahead,
Yes,
Barry,
yes, please. Go ahead, sir.
Why do you give anybody refraction when you have to have two mediums?
Oh, geez.
And Snell's law says it has to occur between two.
I got you.
At
Refraction.
the boundary between two mediums.
I got you, bro. Refraction's a real thing. It's just not to the tune that the globe has made it. The way that they've co-opted refraction is they use it to explain any observation, so it's just overtuned.
Right,
Right.
but I don't think you should be giving it to them. You shouldn't give it to them because they don't have two freaking mediums, and that's where it happens at. Like whatever's happening, it's not refraction.
That's
It's
not
something else. That's
well,
all I think.
refraction's what's in question, and that's what we're showing how we can remove that variable and get a timing that only corresponds to what would be the physical point of it. Because when you look with the globe prediction, throughout the day, they can only do that with refraction. So we have a different geometric prediction for the physical elevation peaks. This is the significance of that. That's why we grant it to them so we could remove it. We show it to them. We let them smell it. They can smell the refraction. They can't use it though. It's gone now.
You should never give it to them.
You
give it to them to begin with.
No,
very bleak.
All right. Okay. Well, do you have another question that's not retarded?
I don't. I just want to do a mic check because someone's turned up my gain on the actual external unit. Is that better?
Sound way better.
There he is.
Excellent. All right.
Yes.
I'll go on mute.
Can I ask a question?
Yes.
Yeah.
So maybe I missed it. There's 231 on the flat Earth.
Yes, sir.
Peak thing. There's 219 on the other one.
Mm-hmm.
Let me make this bigger again.
Yes, sir.
Why are those two different?
Great question. So the first one comes from just the raw plane trigonometry calculation when you have the distance and we have the difference in the elevation between the observer and the mountain peak. So from that, we trig that out. We get 2 degrees, 31 arc minutes. That's just the raw what it would be if this worked out just based off of the pure calculation, right? We're not even measuring it. We don't care, right? And if you went and measured it during the day, it would say 2 degrees and like 17 to 19 arc minutes with refraction or whatever. So it would be way less than what's predicted. It would be this value over here. So when we do the globe prediction over here, how we got this value is we take the that same distance and we do the arc sine, which is over the radius, and that gives us, it removes 27 arc minutes from the value there, which comes out to be about 200 something meters. So because of globe slant, right, because this object, although it might be physically at an elevation of 4,000 meters, right, it's tilted away from you because of globe slant. So it's actually going to be lower by about 200 meters relative to your position at 50.7 kilometers away. So that's how we get when we complete that triangle, we get 2 degrees and 39 arc minutes. Now, when you add in celestial refraction, you get 2 degrees and 19 arc minutes. I'm sorry. I skipped over a step. When we do the calculation, right, we get that difference for globe slant, we get 27 arc minutes. So we're removing 27 arc minutes from our raw flat Earth prediction, right? And that comes out to 2 degrees and 3 arc minutes. And then we're adding celestial refraction, even though this is a terrestrial, would be considered a terrestrial measurement. We're just throwing it on there just to see what happens for funsies, right? To see if there's any sort of mathematical relationship
coincidence or anything like that.
Yeah, see if anything weird happens, right? Now, when we add celestial refraction from the way that we derived the angle using the arc sine of the distance and the radius, we get 2 degrees 2 degrees 19 arc minutes with the refraction correction for celestial. Now, with that, we go to the peak now, right? And we enter the Stellarium. We're at Pike's Peak now, and we turn on celestial refraction. And we get 2 degrees 41 arc minutes for this. So where the globe is saying this, where we're seeing the star, where the light would be coming from, right? They're saying that at that time, at that specific time, the star would be at 2 degrees and 46 arc minutes. So this is where it would have to be occluded at for an observer up here at that time to complete this relationship.
I'm still not.
Alan, can I think that wasn't can I give actually the globe reason for the 219? Because I think that wasn't a very successful steel man.
Well, I also don't understand why
I mean, I know we agree, but I think you got there in a
But
way
let
that I
John
don't
Steelman
really
it.
agree with.
Let's see if it matches up, Alan. It's all good.
Well, I'm not steel manning. I was going to just give you the globe explanation.
Globe slant.
And so to do it, I think the best thing is to look at the diagram that I put in at 553 in the chat. And So the simplest way to understand, it's not about globe slant. It's about drop over distance. It's that 8 inches per square mile thing, if you want. There's a lot of ways of calculating it. But you find out that on the globe, the base of the mountain is essentially 201 meters lower than it is in the flat Earth case. And that's why the globe prediction for the geometric angle to the peak is I get 2 degrees, 17.7 minutes. You might disagree with that decimal place. And then I add a minute or two. I get about 1.7 minutes. But refraction is basically not important. The point is that the flat Earth, the globe Earth prediction for the height of the peak is 218, 219, whatever you want to say. And the flat Earth prediction is 231, 232, maybe if you add refraction, maybe 233. But there's a clear difference. You don't really need to even talk about refraction. There's a magnificent difference between the 217, 218, 219 range and the 231, 232, 233 range that you get. And I think we all agree on that. I hope. I think we agree on that.
Fair enough.
And then might as well keep going, John. What happens when you put the observer on the peak of the mountain with refraction turned on?
Okay, so if I'm going to keep going, and I will, just for a minute, it's really simple. I love the celestial theodolite thing. I think it's a great technique because it means that you can actually test it, as I think Alan was saying at the beginning, you can test the globe versus the flat Earth without having a device that measures angles. And the first step, in my opinion, is you do those predictions that we just talked about. So we now know that globe says 217, 218, 219. Flat Earth says 231, 232, 233, depending on, I don't care. Refraction, no refraction, I don't care. And now we simply find a star that will be occluded by the peak. And we can do two things. We can do one of two things. We can predict when that star will be occluded. You can stick in from the place where it's observed. You can stick in you can stick in the 231 angle and just ask Stellarium, when will that star be observed at 231? Or you can stick in, when will it be observed at 219? And that's one way to do it. The way Mike did it, I think, was to find the time at which it was occluded. That makes more sense. And then just ask Stellarium. You find out when the star was at the same elevation as the peak, and then you simply ask Stellarium, what was that elevation? And Stellarium tells you 219. That's the end of the story.
Stellarium didn't tell us anything in the way that you said it. All we did with Stellarium was take the raw flat Earth elevation angle, go to Pike's Peak, look up at 2 degrees and 31 arc minutes.
Was an observer ever at Pike's Peak?
Nope, not required.
Then why
either.
would you query for an observer angle at a place where no observer was?
Irrelevant.
Great question, because the only way that it would be occluded at that time for me to complete my celestial theodolite and make it 50.7 kilometers long is if that time and angle correspond exactly.
Now, that occlusion occurs by the observer at the observer's location.
Mm-hmm.
What? What do you mean?
And the only way that and the only way that it's going to get occluded based off of what we predicted, based off our angle relationship, because remember, we're using the elevation angle predicted relative to our distance to see what a star would be at that same spot on the thing. So the only way those line up is if it's actually at that position to be occluded to complete that triangle.
Exactly.
Well, the perspective of the observer is the time of occlusion, and it's the angle of the star from the observer at that time. I don't know why you query the top of the mountain as an observer location with no observer there. It's not germane.
Yeah. So here's the thing. We're using that as the crosshair of our theodolite, and we did that to show if we were standing here looking up, if we had our theodolite leveled out and we tilted it up 2 degrees 31 arc minutes, what star would appear there at this time? That's essentially what we're doing there. And then if that same angle relationship show if the star gets physically blocked at that time based on our distance on the ground. One second, someone's hot micing over there. If they could take care of that, please. If they get occluded at that same time, then the geometric relationship shows that the Earth is flat based off of the raw elevation angle being physically 200 meters higher than what the globe would predict.
Does Stellarium provide any flat Earth predictions?
What kind of question is that, dude?
Yes. So this is what we're doing because Stellarium doesn't know where Mike's house was or where the observer is, and you could do this anywhere relative to where you derive your angle at. That it's helping us with the prediction. So this is part of it. Yeah. Stellarium is helping us with a flat Earth prediction. So you guys actually can't predict this. You need to know where Mike's house, or you need to know where the observer is going to be at, so you could refract and change things. So this actually is a mutually exclusive prediction for us using Stellarium.
Right. Oh my God, these questions, dude. These questions are dog shit.
No. It's all good. It's all good.
Does anyone can someone steel man our position on the globe side? Let's hear a good steel man.
Anybody but John. I'm trying, but I can't understand why you're. What is the globe prediction from Pikes Peak?
I don't think anyone can steel man it.
Well, because quite frankly, it's not making sense yet. I'm trying to be charitable here, but to put the
check it out.
Pikes Peak is
in layman's terms. We'll just do a layman's terms explanation real quick, okay? Dr. Mike basically was like, I want to see if my calculation will match up to reality, okay? So he calculated from Pikes Peak, the elevation of Pikes Peak, and the distance to his house, and he was like, okay, with plain trigonometry, it's just 2 degrees 31 arc minutes. There you go. Okay, that's the calculation, right? That's the predicted value. So to confirm that predicted value, he got himself a level transit. Okay, a David Weiss 8300.
David Weiss, David White.
David White, whatever, same thing.
You're good.
David White. And he basically just looked at the mountain peak from his sunroom, and he got 2 degrees 31 or 32 arc minutes. It's like matched up almost. And he was like, that's weird. And he was like, that's pretty crazy, right? He came up with No, that was from the other Theodolite that he borrowed from his stepdad. Hold on, I'll get there. So essentially, it caused him to think, all right, how can I get rid of the refraction argument that I've been hearing in these flat Earth debates? So what he decided to do was use the occlusion time of a star that goes behind the mountain peak, right? So he basically said, all right, I'm going to look at a bunch of stars. Let's see which one gets occluded by the mountain peak. As soon as he found one that gets occluded at that angle, he was like, bam, lock that time in, all right? Now, at that exact time, when the peak occludes the star, then you transport yourself using Stellarium to put the observer on the peak at that exact time the star was occluded.
Why?
What do you mean, why? Because that's when the star was occluded.
Okay, why would you transport yourself to the peak though?
Because that's when it got physically blocked. That confirms, like, when we started off the conversation and Falcami was asking about refraction, like, how do we know? And I was asking, and I said, like, when something's no longer visible, is it still refracted? Like, obviously the answer is no, because it's not visible anymore.
Yes.
If from your position and you can no longer see it, it's not being refracted over a physical object if you can't see it anymore, right?
It's not being refracted over the physical object.
Right. So if we can't see it from our position, then it's fair to say it's no longer being refracted, right?
Correct. It's still refracted. It's just not refracted over the thing you're looking at.
So we can no longer see it then, right? So it's being physically blocked, yeah?
It's being physically blocked, yeah. The refracted light is being physically blocked.
God bless you, sir.
Okay, let's just say it is. All right, whatever. It
No,
doesn't matter.
no,
That's the reason why we go to the peak of the mountain.
No, he got it now. He's on board.
Yeah, but that makes no sense. Like
The argument,
it's still not a reason to go to the peak.
Celestial Theodolite has that horizontal crosshair that is the mountain. That's why the observer is at the peak in Stellarium. That's the whole.
You don't put your eye at the crosshair. You put your eye at the back lens, looking at the crosshair.
What are
you don't just dismantle the Theodolite and go to the crosshair.
This guy, I don't think this guy understands this.
You said your Theodolite is 50 some miles long,
Eric
right?
talk.
How long from the little guy, the stick figure, to the peak? How far is that?
Well, that's fit for Pikes
50 kilometers.
50.7 kilometers.
Okay, so you said a number of times, Alan has said that the Theodolite is 50.7 kilometers long, right?
Right. And you know why that's the case?
When you go to the peak.
But do you know why that's the case? Do you know why we're making that joke?
Yeah, because you got the little lens at one end and the crosshair at the other.
Yeah. Do you know why?
Because that's how far they are between each other.
No, because that's the time when the star gets occluded by the mountain peak. Therefore, we can cancel out any refractive effects between the observer and the mountain peak.
That's not how that works.
Oh, so the mountain peak functions like a crosshair.
Yeah.
Oh.
And a conceptual Theodolite of 3 components. That's weird. It's almost like that was the crux of the argument.
Yeah, exactly. And you put the observer on the mountain peak, and then you look at Stellarium at that exact same time where 39 Aquarii was occluded, and lo and behold, you turn off refraction, you turn off atmospheric refraction in Stellarium, and guess what? It matches the flat Earth predicted angle, because that's where the position of the star truly is, based off the Nautical Almanac. That's why when Alan says,
right?
Yeah, that's why when Alan says, do you guys want to throw out the Nautical Almanac now? No, you don't.
Nope, not using it at all.
Yeah. If you guys want to use the Nautical Almanac, you have to use it at the same time conjunction that we're using for the angle relationship to its true position. Otherwise, what you're doing isn't analogous, and it's just kind of what was the word? Rubbish. It's just rubbish. It's just rubbish. It's straight rubbish, mate. Oi, she wanted more than just the Theodolite, Mr. Churchill.
Oh, it's rubbish.
Yo, he gets it.
Yo, who gets it? I missed it. Was it?
We can't hear National Show.
Oh, I had him muted. What's up?
Yeah, there's no need to bring him up.
Oh, yeah, there's actually no need to unmute him, really, to be honest. Anyways, did anyone else want to contribute to the conversation?
I think they are, yeah.
Does anyone actually
curious,
have
though.
a reputation? Like a real reputation?
That's hilarious. I knew it wasn't going to be worth it to unmute him. He didn't say anything, did he? He just kind of yammered. Yeah.
He said Stellarium's globe math.
Right. Okay. Cool beans.
That's
so that's awesome that we're using globe math to use a flat Earth prediction that corresponds to a specific timing that the globularists are trying to co-opt while ignoring the geometric relationship of the triangle that created the intersection point in the first place.
Can I ask a quick question? I think I might have missed something in the initial discussion. So
yeah, go ahead, Daza.
When Mike measured the angle to Pike's Peak, that was during the day, was the angle measured at the time of occlusion as well?
No.
Okay. Yeah. So we don't have an angle measurement at the time of occlusion.
Yeah, we do.
No. You've got an occlusion, but you haven't got an angle measurement.
Oh,
the angle doesn't change during it all, right?
You know, like the only way that timing would work is if it would trigonometrically be a flat baseline all the way through and through, and that would be parallel from the peak to the star from the ground to the observer. So, like when you say like you don't have a measurement of it, and you say that's not true, but yet you're trying to co-opt the measurement, that's kind of weird. So I think you do know that it's true.
Wait. To answer Daza. No, multiple stars. Okay. Daza, real quick. The reason why the measurement holds true, or that angle holds true, is because in Stellarium, you put yourself basically right where 2 degrees, 33 arc minutes, 32 arc minutes is, and then you can time when any one of the stars that pass by that angle, right? He didn't have to use 39 Aquarii. In fact, he used 12 other stars. So it's just a point that it matches because that's exactly when the star gets occluded at that time, at that angle, thus teleporting yourself to the top of the mountain to confirm that angle. Hey, let's look at Stellarium, take off atmospheric refraction, look up at the star, and it matches the angle. It's like extending a ruler. What don't you guys understand?
It confirms where we started with, right?
Yeah. It's really cool and simple,
I just
and
think you
anyone
better
can
have
recreate it.
two measured angles, that's all, at the time of the occlusion.
Oh, we do. You can measure the
Oh.
timing something gets occluded to complete a relationship.
No.
and
You haven't
calculate it
measured the
out.
angle from Pikes Peak at all, right?
Can we get the images for Blodgett's Peak, pretty please?
You've just assumed.
Yes, they are forthcoming. You just assume that you would see it there. No, sir. The nautical almanac from Stellarium told us that that's where it would be, and if that point corresponds to a physical intersection at a mountain peak that shows the same angle relationship from our position 50.7 kilometers away, then that is what it is. That's why Ruhif's trying to co-opt the measurement and ignore the fact that the mountain peak elevation is, from the flat Earth prediction, is what creates the timing necessary for it to be relevant to the where the angle was derived, which is physically different than the globe elevation angle. As John noted earlier, it's about 200 meters different. So it's a timing difference. So the timing that's measured, there's only one timing we all agree on, right? So we all agree that there's only one timing measured, and it doesn't correspond to the globe Earth prediction to complete the same geometric relationship for the true position of the star. The globe only exists within these refraction corrections that aren't physically manifest, because what we can see here, right? We're going to look at John's diagram. You can only do a bastardized version of representing the celestial theodolite here. So what we're starting off with is globe prediction here, 2 degrees, 19 minutes. This is adding refraction in from the peak to the observer, or from the peak to the observer, right? And when we get over here, he's using the 232 nautical almanac true position of it to keep it in alignment. But if the elevation angle, as noted by the glob, which we derive from here, the star would be in a physically different position. It wouldn't be here. It couldn't physically be here because the timing would be different, and the timing that's measured doesn't correspond to this diagram in the way that it's presented here. It corresponds.
Do you mind
to
if I
this diagram? Go ahead.
Since that is my diagram, do you
Absolutely.
mind if I actually take people through it? Maybe
Absolutely.
you can bring it up for.
Absolutely. Go ahead.
Yeah. So what I've tried to do here is to draw really a scale model. This is a scale drawing. All of the directions are scaled properly, but the vertical scale is 15 times the horizontal scale. And what that does is it makes that path much more curved than it is in reality. That is a curved path, and it is 15 times as curved as the actual path, which I found kind of remarkable, just to understand kind of what a small effect refraction is. But in the globe model, let's start from the top of the atmosphere, go the other way. The story on the globe is that, and this comes from Stellarium, combination of Stellarium and refraction and predictions to the peak, etc. That ray comes into the atmosphere at an angle of 2 degrees, 5.5 minutes relative to horizontal at Heffron's place. And then it proceeds to refract downward by about 9.5 minutes. That's celestial refraction down to Pike's Peak, so that by the time it gets to Pike's Peak, it's headed downward at 2 degrees and 15 minutes. That's a very tiny 9-minute extra refraction. And then it continues on to Heffron's place, curving another 4 minutes through the thicker part of the atmosphere from Pike's Peak down. So when it gets to Heffron's place, it is now heading downward at 2 degrees and 19 minutes, as Stellarium says it is. Stellarium says that from Heffron's place, that star was viewed at 2 degrees and 19 minutes. And that happens because it just passed over Pike's Peak and joined light from Pike's Peak at that point as it headed down to Heffron's place. Now, if you want to know the angles of all those angles that are in red, if you want to know what they look like from Pikes Peak, you have to take into account the fact that horizontal at Pikes Peak is tilted negative 27.3 minutes, as shown down there in blue. So to each of those red angles at the top, you have to add the 27.3 arc minutes. That's why the star is geometrically at 2 degrees 33 minutes from the top of Pikes Peak. But that's not very important because you can't see that. What you see is the visual star, which you get by taking that 2 degree and 15 minute direction from the peak and adding the fact that horizontal is tilted by 27.3 arc minutes. That gives you the 2 degree 42 minutes that an observer at Pikes Peak would have to look to see the star. If you wanted to see the star from the top of Pikes Peak, you'd have to look up at 2 degrees 42 minutes. So that's what that diagram is supposed to show.
All right, cool.
Okay.
You want to break it down, Beast, or you want me to do it?
Yeah. Well, let me just make something very clear here. So you can take any plane trig, right? Any distance away from a peak of a mountain, okay, and use any star you want. Wait for that star to get occluded, okay? And just using a plane trig calc, it just coincidentally matches what Stellarium says with atmospheric refraction turned off every time. Coincidentally. Like, you guys have to admit that that's some type of crazy cosmic coincidence.
It's not that crazy.
Because it almost seems like they used flat Earth elevation angles to the stars to create the nautical almanac in the first place. That's what it seems like to me.
This is why it's so important that we do this with other mountain peaks. I actually think that what happened with Mike Heffer, and this is just my speculation.
Hold on 1 second before we get into your speculation, because we have actual measurements on the table that need to be dealt with. Okay. So what we have here, right? You've got refraction over here, 27 arc minutes difference for the elevation difference, right? We're refracting here. You're using the true position here, but you're saying that an observer here would see the star higher than what it is. Now, that's going to put it higher than, like, if we're talking the light being blocked by the star, then the occlusion timing. So that geometrically doesn't work out. That's why this is the only way that it works. And we're using the true position. It lines up with the angle right here, and it lines up with our angle. No further calculations, corrections. It never knew our distance or anything like that. Right?
Okay, so there's a misunderstanding there. Go back to my diagram. The direction of the star, the visual direction of the star, is that red ray, period. Anybody who wants to see the star will have to look in that direction. Now, that direction makes a 2 degree and 19 minute angle with horizontal at Heffron's place, but it makes a 2 degree 42 minute angle with horizontal at Pikes Peak. Everybody looking at the star will have to look in the same direction. It's just a question of what they measure their angles with respect to.
So, John, so if you put the observer on Pikes Peak and you take off atmospheric refraction, what happens?
Well, things change a little bit. I mean, here's the nice thing.
What does it do?
Seconds.
So it moves the geometric position of the star, but we actually don't have to care about the geometric position of the star. One of the things I forgot to say before, that's another nice thing about the celestial theodolite, is that when you look at the star and you look at the peak, there's very little refraction going on from the peak to the observer. That's such a small amount of refraction, as I was saying at the beginning, that you can actually just forget about it if you want. It doesn't make the difference between whether the globe prediction or the flat Earth prediction is correct. The light from the star is coming in the same direction to you from the peak that the light from the peak is coming to you from. And then when you look up and you see the star coinciding with the peak, if you see that star at 2 degrees and 19 minutes, which you do, that's what Stellarium says, that angle is the same angle that you will see the peak at. And that's confirmed by Mike's later Theodolite measurement that the peak is at 2 degrees 18 minutes. So all three of those measurements confirm that as viewed from Mike's house, the peak is 2 degrees and 19 minutes above the horizon.
Anybody else have any questions though? Because I mean, this thing is really.
Sorry, my mic was muted. I was replying to the whole time.
You're good,
dude. So what you're doing, right? The star doesn't get occluded at the refracted time for both observers. Our angle relationship is with respect to the true position of the star, the true so-called right position of the star, which is derived off of a flat baseline. The only way that would work, the only way that this timing would match, is if the elevation angle is actually 2 degrees and 31 arc minutes, because that's the only timing that would put the true position there to get occluded, right? It doesn't matter where the refracted position is, where you think it's at, right? We only care where it isn't, when the star isn't there, okay? That is the significance of this. That is what keeps being ignored here. And you keep talking about bending light coming from this and that and all these different things. And it's bending from here to here. None of that matters. All that matters is we don't see the star anymore, and geometrically, we're referencing the true position of the star with respect to the elevation of 2 degrees and 31 arc minutes on the top of the peak of this mountain, which we derived from being 50.7 kilometers away and calculating what the difference would be based off of our elevation of our observer point. So that timing is mutually exclusive to us. You don't have a 2 degree and 19 minute timing that corresponds to the true position of the star to be physically blocked. It's not, the star isn't going to be blocked at the same time. That is the significance here. That is why that is why this works. You keep ignoring that, and it's like,
so 2 degrees. It's okay.
Then,
it's all right. 2 degrees.
No. I'm not done. And before I forget, this so-called refraction correction, this difference in globe slant here, right? This 27 arc minutes that has to be removed because this object is in lower elevation relative to this observer, right? Remember what I told you guys to pay attention to this? And they're going to contend the calculation, but then slightly redo it and blah, 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 right? This is adding celestial refraction both times to the arc sine of the distance between us using the Earth's radius. We make the same calculation and predictions. We're showing this difference only exists as a refraction correction. And the true elevation of this peak is not 2 degrees and 19 arc minutes. If it was, then this time would be different. I'd be here telling you guys we were wrong, boys. That's the significance of this. I don't think people fully grasp this, and I think the Globe lads are underplaying the significance of having these two angles line up together.
Okay, so a couple things. The 27.3 degrees is not a refraction. It's not a correction. That's based on a radius of the Earth that we didn't make up in order to
I know what it's based
Mike
on.
Halperin's observation, right? That has nothing to do with refraction. So that was one thing. Number two, it is not. No, hold on. I have one more thing.
You're right.
If you say that you want to use the true position of the star, but if you ask Stellarium what is the true position of the star from the place where the star was being observed, it will tell you that it was at 2 degrees 5.6 minutes. So if you want to look at the true position of the star, you have to look way down the mountain at 2 degrees 5.6 minutes in order to see the true position of the star. That is the direction to the true position of the star from the place where that star was observed. But I'm not claiming that you should do that because you can't see the true position of the star, and no mountain peak can block the true position of the star because that's not the path that light takes to get to your eye. A mountain can only block the light if it gets in the way of the light, not just getting on the line between the observer and the star. But none of that really matters.
Yo, hold on a
It
second,
doesn't
John. Hold on a
actually
second.
end
You're
up
hold on.
making
Whoa.
any
You're
difference.
you're
Okay, I'm
horror
done.
waffle. Yeah, you are, dude. It only gets occluded at that physical timing. Agreed. And that timing corresponds to our angle measurement. God damn, dude. Like,
It's all good, dude. They can't. I don't know if they. I don't know. It's very simple. Do you agree, John, with what I said earlier?
no.
That,
Hold on. One second. You keep making it singularly about Mike's house. This isn't about Mike's house. This is about the geometric relationship of the timing in which the true position of the star intersects with a mountain peak, and then it's no longer there, as you said. Right? When it's no longer there, that's what we're concerned with. That's what makes my instrument 50.7 kilometers long. My observation point isn't necessarily Mike's house in the way you think it is. My instrument is 50.7 kilometers long, and the only way that light gets blocked by that, right, is when it's not there anymore because the mountain peak physically blocked it, which you agreed with, which was derived, and the timing and angle was based off of a flat Earth calculation. We never told Stellarium where Mike's house was.
Right.
But it's important to understand that the timing would only have been the time that you put into Stellarium was only that time because the observation was made from Heffron's house. If you had made the observation somewhere else, the occlusion would have happened at a different time.
No shit.
Yeah, that's our point. That's what completes the triangle, John.
My point is just that Heffron's
Hold on,
house, you
John.
can't claim that it
That's
doesn't matter.
That's what completes the triangle. We're saying it does matter. You guys are throwing out the other end of it. Jesus,
No.
did you guys just hear that? Or am I tripping out? Did he just try to? Did he just try to flip the? Whoa, dude.
Let me
John.
just explain it. Like, it's very succinct, man. It's very simple. And John, you would agree with what I said earlier, right? That
Say it again. Let me see.
Okay, so if you take any plane trig calculation, right, distance to the elevation of the mountain, you get your angle, right? And if you take that angle and put yourself, like, from wherever you are, right, 30 miles away, 100 miles away, whatever, that prediction, right, that angle will match.
Can I just talk just for clarification? So you're saying you're going to use the flat Earth. You're going to calculate the geometric angle to the mountain, right?
To the mountain, correct.
Okay.
This is just calculation, not a measurement.
The 231.
231, correct. And then if I take, any star that gets occluded by that mountain that I'm looking at, right, that peak, boom. As soon as that star gets occluded, mark down the time, that exact time. Then I teleport myself as the observer to the peak of the mountain at that exact same time. And I look at the star that was just occluded. And I take off atmospheric refraction. Would you agree that it will match that flat Earth geometry every time?
No, that's absolutely not true. It did in this case, but it won't in most cases.
Okay, so what about the other peaks that Dr. Mike did? And it does match up.
Well, I haven't seen that data. I have asked him repeatedly to send me that data. He has not done so.
Yeah, so Jesse Path of Light's here. He might be able to help. He inputted the data and compared it to Heffron's house, which we know you guys like to do, and it was off by 33, like roughly 33 arc seconds for everyone. But I think, if you want to,
I have seen the data that Jesse has, and if somebody wants to vouch for it, then I will further say that when I analyze that data, I find that it doesn't agree with either the globe or the flat Earth. But I haven't tried to do your method. So I am puzzled by that data, as Jesse is as well. I don't know.
If you didn't do that method, then you didn't do the flat Earth prediction. Then,
I think I didn't do your method. I will concede
there's only one method though. So
yeah.
The thing about it is that the data doesn't make the Pikes Peak data makes sense to me. I can't make sense of the other
Yeah.
data.
Yeah, Shane just posted a bunch of other peaks and stars.
Okay,
Hey,
let me see if that's the same thing.
Rue, if you're
Someone-
super Rue, you're far away from your mic, or it's too low.
All right. It's not off by 33 arc seconds. It's 33 seconds of time.
Can't hear you, Rue.
That's why we want the images.
Oh, thank you.
Anyone can
33
hear him.
seconds. Thank you. Actual seconds. Got you. Yeah, I actually asked him for those. He's gathering them now and putting them together. That will be made available hopefully soon. Oh, you guys will be the first ones to know. I definitely want it as well.
We'll get the actual images with the timestamp from the telescope, right?
Yes, that's what he's putting together specifically to make sure everything is good to go.
No, it'll be great. I think so I'll probably just wait for that. I'd like to get it from the horse's mouth.
Cool. All right.
Yeah,
So
see, he does all those peaks. Yeah.
Yeah. All right. So does anyone have any other questions, comments, or anything about the celestial theodolite?
Yeah,
I have a
Alan,
question.
this is McMurdo here, Bobby Gazette. While we're waiting on this horse, I just had a quick thought and question for you. Have you ever considered nuh-uh, and why would they lie?
I have an actual question.
What's up, Mal? Man.
I heard sort of contradictory claims. Did he actually measure the angle to the peak or not?
Yeah, he measured it during the day twice. The first time the instrument gave an agreement that that agreed with the raw flat Earth prediction, and then he measured it again with a what they would consider like a more up to date theodolite, and that measurement gave an agreement that corresponded within 1 arc minute to what the globe predicted for 2 degrees and 19 arc minutes during the day.
So what was
That's
it?
completely irrelevant, right?
What was it when the star got occluded?
Ooh, great question. When the star got occluded, the angle corresponds to 2 degrees and 31 arc minutes.
Well, I think that's a little disingenuous. The point is he didn't use the theodolite to do that. I mean, this is another argument.
My theodolite is what occluded the star in the first place based off of an elevation angle based off of my distance. So the physical relationship there, and geometrically speaking, would only be completed if the star gets physically blocked by an object that is at that elevation relative to me using plane trigonometry. It's mutually exclusive.
Well, Alan, can I just ask you what I asked you this before, but I still don't feel like I've gotten a good answer. If you do, just humor me. If you do tell Stellarium to consider an observation to be made from the place that observation really was made, I know that's crazy, but just humor me. If I tell Stellarium to use that as the observation point, and I ask it, how high in the sky would a 39 Aquarius be seen at the time that Mike Heffron said it was occluded? How do you interpret the fact that Stellarium will tell me that visual star was 2 degrees and 19 minutes above the horizon? How do you
with atmospheric refraction turned on?
One second.
But it would have been 2 degrees and 17 without. How do you deal?
I got you, John. I got you.
You
don't have to keep asking it over and over. I can just answer it now. I've already answered it multiple times, and the fact that you keep rephrasing it in public as if I haven't answered it now, that's a misuse of the application and how we're using it. My theodolite is the crosshair is the mountain. It's obstructing it. Right, you can place.
But I think that's a
Stop,
refusal to answer
dude.
my
Why are you interrupting me though? That's that's the better. You thought I was done while I was in the middle of speaking. That's really weird.
Okay, I thought you.
That's really weird. My theodolite is the size of the distance to the mountain. That's what's physically making the occultation, as you noted earlier. Right, when you
and I get that. Oh, sorry, I really did think you were done.
Man, John. One second, dog. I'm just gonna have to mute you put you on zero volume for a minute because no, I'm not gonna server mute him, but I can't deal with you interrupting me in the middle of my thought because I already answered this for you multiple times, and the way that you frame it to begin with and then ask it repeatedly over and over again, preventing me from jumping in to answer is disgusting. And I hate it when you do that. So if you start doing that again and acting like you've never heard the answer before, because this is what the whole presentation has been about this entire time, has been about covering this. So the fact that you're like all mystified, like, oh, what would happen? We've already agreed to that multiple times. Look up through the chat. Like, this is not what's in contention. That's a misapplication of the geometric relationship that's being drawn here. This is what can't be addressed. Our measurements correspond to the so-called true position of the star, which intersects a mountain peak that is derived off of a flat Earth elevation angle, which prediction, which puts it 200 meters higher than the globe Earth prediction, a completely different time for the occultation. That's what is significant here. When my instrument is the size of where I'm at to the thing that's occluding it, that's why it matters to use the angle here as well, to have that relationship. You're talking about having the star way beneath the thing, way beneath the mountain, refracted up over here, refracted over here. None of it matches up with what we're putting forward. Straight trigonometry, straight plane trig. What you're trying to make this about and how you're framing this is gross. I'm not going to keep letting you do this publicly. That's insane. I understand it. I did the flat Earth prediction. You either don't understand it or you're lying. If you did it right, you would know what to do. Now I am done talking. I'm going to turn your volume back up.
Okay. So I object, I guess, to your calling it dishonest. I am trying to be as clear as I can. I respectfully, Alan, I don't believe you've answered my question. When I ask this question, you always tell me why you do what you do, but you don't answer the question as to what.
Did you not just hear me say yes? Did you not? No, man. You're literally restating it as if I haven't answered it, and as if I didn't just answer it. I'm not going to let you do that. That's not what's in contention here. Where it is at Mike's house with that relationship isn't what's in contention. Address the actual point or just say nothing, because you're not going to just keep doing this over and over again where you reframe it in this weird way.
Okay, then I think there's no way for me to ask the question. I have not gotten an answer to my question. I just want to be really clear about that. I think everybody heard that what we got was a recap of what you do, not why you dismiss the 2 degree 19 minute that Stellarium reports. You just say that's wrong. You don't say why you think.
I don't say that it's wrong. I say that it's a misapplication of the geometric relationship that we're establishing. You're lying now. What was said is on recording. People can go back and listen to it. My answer is recorded.
I'm done.
Yeah, you are.
Listen, it's kind of crazy to not engage with the argument as it's presented, right? I mean, so if we put something forward as a celestial theodolite as an argument, for no one to engage with it as presented is ridiculous. To have to straw man it excessively, right? Which is what you're doing when you're framing it back from the observer, trying to put refraction in two places. If you could just engage with it as we presented it, meaning the mountain is the horizontal crosshair, right? That's how we have a 50.7 kilometer theodolite, and we have a vertical crosshair with Stellarium. Those three components are the components of the celestial theodolite argument. So for you to argue against the very nature of the thing without understanding its components is silly, right? How can you claim to refute an argument when none of you have correctly steelman so far? Anyway.
Yeah, can we get a steelman, actually? That'd be nice.
I can steelman your argument. I can tell you, I can give you the procedure to do. So what you do for your procedure, what you do is you find a peak, you calculate the flat Earth angle to that peak, you look for a star that will be occluded by that peak, and then if you wanted to predict the time that you expect it to be occluded, you put an observation point at the peak, and you look for the time that the true position, not the visible prediction, not the position, you look for a time that the true position of the star, one that can't be observed, I'm not deviating from the Steelman here, but you look for when the true position of the star will be at the same angle observed from the peak, that the peak is observed from the actual observation point on a flat Earth. And it's the matching of those angles that you use to make your prediction. And I propose that we test that by using that method on other mountains. And I know that Mike has done these other mountains. We'll look at them and see how those work. There's something weird about that data, if it's the same data that I've seen, because unlike the Pikes Peak data, I can't make sense of it. So we'll have to see. Well, I don't know why. I have an inkling because I have some other data that I just shared with Ruthie, and it seems to me there's something very peculiar in that data, and I'm going to be interested to see if Ruthie gets the same thing.
Yeah, one thing you should add to the Steelman: why this concept was developed in the first place.
Well, can I tell my story, because I think I do know how it was developed.
One second. Before we get to that, there was one important point that needs to be covered here, right? The true position of the star, which no one can ever know, etc. Right? Agree. But
you can't know it.
1 second.
Sorry.
But at that time, to complete that angle, that is suddenly when the star is no longer visible for an observer 50.7 kilometers away. That is what makes this significant. I think you would agree, and that's why you want to do it on other locations just to be sure. And I think I just want to reiterate the importance of that. That is
right.
All right, cool. So that we're all in agreement then.
So can I, because I think I know what probably happened, and this is a little speculative, but I think it makes some sense.
Okay, 1 second.
I think
if you tell it, can you, because you said that you typed this out earlier in our Discord,
yeah, right.
and I typed you out a nice response to each one of your points. So after you say it, is it cool if I just read off a response to each one of the things you're asking?
You can if you want. I don't know that it'll play as well that way, but just interrupt me whenever you want to say something, okay?
Yeah, why don't we go one for one so that it's trackable? Start with your point.
Okay, I think you might find that that's not the best way to present your argument, but whatever you like. You can just interrupt me when you want, if you like.
Right, go ahead.
Step one was, I think the first thing Mike did, well, I don't know if it was first, but anyway, one of the first things he did was to use his David Weiss transit level, and he got a value of 2 degrees and 30 minutes for the elevation angle of the peak. Did you want to say something about that?
You have the floor.
Okay, yeah, I thought so. And then the next thing was, and maybe this was actually the first thing, was he calculated the flat Earth angle to the peak and found that it was 2 degrees and 31 minutes or something like that. Those were probably in reverse order. I probably got those wrong, but anyway, those two things were obviously first, I think. Your floor for a second.
How do you know that?
Oh, are you
Taylor? Let him get through the whole thing.
Okay, you're good. Okay. Then let's see. So then I think I don't know this, but I would imagine that he would have then come up with this celestial theodolite idea and found a star that was going to be occluded by the peak, and figured that the best thing to do would be to find the time that it's occluded. And so he did that. So he got the time that it was occluded. I think that was probably the next thing that happened. So that would be my guess for the next thing. Response?
Please continue. You have 2 more to get to.
Okay. And then at that point, I would imagine, I don't know if I said this before, but I would imagine that what he did was probably ask Stellarium what the elevation of the star was at that time. Now, I'm sure you're going to want to respond to this, but that's what I would have done if I were an astronomer. I would have asked Stellarium, what was that elevation at that time? And I suspect he didn't like the answer. That's my suspicion. You probably want to respond to that. No?
Is that it?
Suspicious?
No, but I thought you might want to respond to that because I think that's what
I
probably
said,
happened next.
John, I said get through the whole thing. I didn't say keep asking me if
Okay.
I'm
I thought you were
continuing.
okay. I'm
You have the
sorry.
floor.
Okay.
Continue. Knock it out.
Okay, good.
Get
I
it
didn't
all.
realize
Get it all out.
All right. Then, because he didn't like that answer, then the next question was, well, what? He might have turned the atmosphere off. He would have liked that answer even less because that puts the star even lower. So using Stellarium from the place he observed was out. And then maybe it occurred to him, well, I wonder, and he might have thought something along the lines of what you're saying here. Oh, maybe that's where I'm occluding. Maybe I should go to the peak. And then he went to the peak and he would have asked Stellarium, and Stellarium would have told him 2 degrees and 42 minutes. He wouldn't have liked that answer either. But he then found that in that case, if he turned the atmosphere off, he got an angle that he did like. And then the fact that that angle was no refraction, just like the angle that he calculated to the peak, which was also no refraction, that just clicked for him. They're both no refraction. They're both the same angle. This looks like what's going on. The mountain is occluding the light from the star, even though the light didn't travel along that path. Use the no refraction. And then he thought, oh, this method actually makes refraction irrelevant because it just automatically compensates for it. I think that's probably what he really thought. So I'm done.
Fantastic. All right. So that was insane amounts of speculation followed by what phrasing it like, oh, he liked this better because he has an agenda to do or whatever. This is geometric calculations and triangles. The numbers come out and they are what they are. Specifically, this was done to determine whether or not these calculations were true. He didn't like the calculation. The calculation is what it is. It's a triangle completed based off of the distance in the elevation and the elevation difference. That's not he doesn't like that. You think, dude. Anyway, that's an absurd argument. You keep making it about where the star location, where you want it to be. This is about where it isn't at a specific time that corresponds to the raw elevation angle from the flat Earth prediction. This isn't about him making the measurement from his house and he didn't like it. Nobody cares about the daytime measurement. That's what's in contention here. So using that to reify it from that position isn't the measurement that's being made with the celestial theodolite to confirm the elevation angle of the mountain. That is why we're using the true position of a celestial body as the reference, and that it just so happens to coincidentally no longer be visible at the same time of when it shares an angle relationship with an observer 50.7 kilometers away with which is what the mountain would be for that observer, the physical elevation of it, which is different from the globe prediction. That's the significance of here. You trying to obfuscate, say that this was about one particular measurement, call this whole thing into question, and oh man, and act like
Question is, if you don't
one second, Ruhif dog, I'm not done yet. I had to listen to that whole thing about how he thinks this was backwards derived, and I'm not done tearing that apart yet. That's insane. So you can just hold your horses.
That was Taylor.
That was Ruhif. Did you hear Ruhif
try
chime
to come
in?
Yeah, he's coming in super low.
He's coming in
But I
super
did
low though.
get it.
But also both of them. So listen though. The angle relationship with the true position of the star where it's being referenced at shows that it just miraculously gets occluded, even though you would predict it would be higher and simultaneously lower, right? It corresponds with that same angle relationship. The geometric significance of that shows that it's only possible if both of these baselines are flat. All right. Go ahead and what was your question, Ruhif?
So you don't disagree with the daytime measurement, but is your claim then that it gets refracted up to 231 at night? Like, what's the explanation for the 231 at night and 219 for the
Yeah, so 219 during the day is atmospheric conditions during the day. There is refraction and things, and it makes it appear lower. So instead of being 231, it comes out to be 219 due to refraction conditions. And Taylor, don't you have a paper that also signifies the same thing for a distance of 100 kilometers away? I think it's, what was it, 20 arc minutes of refraction for compression or whatever. And then, so like we're at half that distance. I mean, it almost just works out on the face of it, if that's if I'm arguing that correctly, Taylor.
Yeah, I one this weekend that specifically is measuring like how many arc minutes, how many arc seconds is dropping. But they have multiple papers. I've actually sent you some, Ruth, about how things progressively get worse throughout the day because of the temperature gradients. And yeah, I think that I've already shared that data with you. But if anybody wants it, I can put them in the chat.
And the hospital paper, what happens at nighttime in the hospital paper?
It gets taller.
Yes.
Right.
Yeah,
Exactly.
it's almost as if its true geometric physical location is different at night than it appears to be during the day. And if only there was some way we could use a star being occluded by it to tell the difference of when it's physically there to block it with respect to its geometric angle, based on our distance from it. Any celestial theodoliters in the chat?
How much does it change in the hospital paper? Does it change by what, 13 or 12 arc minutes?
Because of the refractive effects, that was the entire reason Dr. Mike came up with the celestial theodolite concept in the first place. That was the last thing that John forgot in the Steelman. That was the only thing that John forgot in the Steelman, was why he did it. That was the reason why.
All right, but I mean, it involves putting the observer on Pike's Peak and then turning off refraction. If you're on Pike's Peak, let's say you are up there, are you going to measure 247 or are you going to measure 233?
Doesn't matter. The star only gets physically blocked at that time by that, and that's why it lines up for that geometric time at that specific time.
But we're on Pike's Peak.
Yes, that's where we started with. That's where it would be.
Listen to the question. We're on Pike's Peak, right? So there's nothing obstructing the star. Will you see it at 233 or 247?
I think it's 242 or 231 or something like that.
Well, where you would see it doesn't matter. It's physically blocked. So where you would see it would correspond to that same angle. That's the angle we started with. That's where we started.
No, we're on Pike's Peak, right? So there's no occlusion.
Do you not hear me? Same angle. Hello? That's where we started.
I understand what you're saying, right? But you keep saying that's where it got blocked, and I'm saying we're on Pike's Peak, so there is no blockage. What angle would we see the star at? 233 or 247?
If you don't have refraction on, 230.
Right. So you're claiming that there's no refraction then, because you claim you would see it at 233.
I don't. We're not concerned with where the star is after it's been occluded. That's what you're not under. We started with Pike's Peak for the physical location to determine whether or not if it physically gets intersected by a freaking mountain, dude. That's what.
Understand?
Yeah. Do you, Ruhif? Do you understand?
The mountain's not obstructing. We're on the mountain, and I'm asking you, if you measured it in reality, would it measure 247 or 233? If you say 233, then you're claiming there's no atmosphere and no refraction.
The angle that we started with is 233.
Alan, let me know when I ask the question.
The only way that the mountain could block it is if it's actually at that elevation angle.
Okay. The question is, I'm
on Stellarium right now looking at it, bro.
Okay.
It's the same angle.
Take out an actual theodolite and point it at the star, what would we measure with an instrument?
You would measure it at the place that it isn't when it's being blocked. Do you understand?
On the mountain.
246. Whatever here with refraction. 246.
Okay. So you agree that we would see the star at 246?
It doesn't matter. It's not relevant.
Sure. It could be anything between up above that. It doesn't matter. What's relevant, Ruhif? Sorry, I was misunderstanding how you were trying to listen. That doesn't matter though. What matters is it's no longer visible at that intersection point based off of the flat Earth prediction. which means that mountain, to actually block it there at that time, has to be 2 degrees and 31 arc minutes.
Okay, but you just gave me confirmation that you would measure it if it had refraction incorporated. So there is refraction between the mountain and the edge of the atmosphere. Is there refraction between Mike and the mountain?
When you're observing things that are illuminated between you and the mountain, what the difference is, what you were trying to do earlier by referencing something that's on the mountain and then turning it off, which is incoherent. We're talking about something that's going behind it and is no longer visible. So we have a timing in which we can denote when it's been intersected, from when we could see it, from when we can't. So what you're doing isn't analogous. And the purpose of being on top of the theodolite and doing the measurement, right? The significance here is that we're using its quote unquote true position, right? And then we can no longer see it at the same time with an angle that corresponds to the same thing. So it doesn't matter when you're standing on the mountain and making a measurement of the star. That's not what the prediction is. That's not the geometric relationship that we're drawing. We're true position of the star. This only corresponds. Listen. True position of the star, and then miraculously, coincidentally, somehow, it gets blocked at the same corresponding angle, Ruhif.
Yes, I understand your argument. You keep saying that we don't. I'm telling you that we do. And I'm pointing out the flaws in it, right? You accept that if you are somewhere, like on Pikes Peak, you need to turn refraction on, and that gives you an accurate angle, but refuse to accept that if you're at Mike's house, you got to turn it off. And it gives you the wrong angle.
No, we're not, buddy. We're turning it off to see when it physically intersects with a mountain. Viewable,
right? The curved
right?
path.
Viewable from Mike's house.
Yes,
okay,
the curved path of light.
Stop with the curved light path, right? Nobody cares. It's no the light. Stop. The light is no longer there, though. That's the significance of it.
So there's no angle to measure. But the
angles measure the what? What are you talking about?
The instant
Dude,
before it got occluded, it was 219, correct?
No. Obviously not. That's the significance of this. What do you mean?
Oh man.
It only gets intersected at the time that corresponds to the physical elevations predicted by the flat earth calculations. Stellarium doesn't know where Mike's house is at, dog. Did you know? Do you keep forgetting that, Ruhif? Does Stellarium know where Mike's house is at, Ruhif?
I'm going to go and just say that the globe predicts this, and you agree that the globe predicts this, and
it doesn't predict the timing for the occlusion for Mike.
Yes, it does.
No.
I have a screenshot of you saying it.
Not with respect to his true position.
His true position is his fucking house. Oh, this is insane.
True position of the star, dude. The physical object occluding it is 50.7 kilometers away. See, the only way that this could be argued is through obfuscation and just dishonesty, making it about where the star is visible. We don't care where the star is visible at. We care about the prediction angle corresponding to when the star isn't. That needs to be clear for everyone. That is the significant purpose of this. That is why they're trying to take our timing from us and act like it's a globe prediction from his house. They don't have the same geometric relationship. They have to use refraction here for one and not the other position, because it doesn't make any sense for them to do that.
Can I present how I would go about using? Because I love the celestial theodolite.
No, John. No, you actually can't. You gave enough speculation and poisoned the well enough and tried to reverse your position twice and co-opt mine. You've actually said quite enough. Does anyone else have anything they want to add? And maybe we'll circle back to you at the end if I'm super bored.
I do.
Wait, I have one point to make about Dr. Mike. So Dr. Mike.
No,
Taylor.
Taylor first.
Taylor's
and
been waiting.
Yeah. Taylor first.
Okay. I was just going to ask Ruhif. Ruhif, I shared with you papers showing how things.
I don't think he's here anymore.
Oh, can y'all hear me?
Yeah, he's not here anymore. He's not here anymore.
Oh, okay. Who's another glober I can ask? Okay. So then if we know that things can drop and rise throughout the day, and I have, papers to show that, then what would be the best way for us to measure if something's actually there without forcing the line or doing something like that? What's the best way we could do that? What is the best way to tell if an object is actually there? Yeah. Okay, so whether we can see it or not. And I just told you how things can shift with atmospheric conditions. So what would be the best way other than that, that we can actually determine whether something's there or not? So things don't shift throughout the day. Things don't get higher and lower with atmospheric conditions.
About that. I think, in fact, Shoebill might be able to say more about this, but I think in something like the visual height of Pikes Peak from Mike Heffron's place, my suspicion is, and I'm just guessing, because of the fact that I don't think the atmosphere changes very much at high. The only time you get weird optical effects is when light travels right above the ground. You get crazy miraging things. But when light travels through free, unobstructed atmosphere, standard atmosphere is a pretty good thing, and you can calculate index of refraction gradients from that. And I've seen at least one video showing that long distance measurements that don't pass over a horizontal surface are very stable. So I'm not sure what you're referring to or how much variation you're talking about.
Yeah, let me just respond, because actually whenever they did that measurement, finding that the mountain shrank throughout the day, they were above the quote unquote ground. And they were, I can't remember how high they were, but they were like on top of another smaller mountain, and they're looking at another mountain, right? And things do change throughout the day. And if you're going to say that, we can calculate for refraction, then can you tell me the maximum amount of atmospheric refraction we could have? What is the
Yeah,
most?
well, you can have a lot if you're talking about over hot pavement. You can have enormous amounts. You can get curvatures, of 100-meter radius. So tremendously curved light, but not usually when you're 100 meters above the surface. Things start getting a much more uniform, much more like standard atmosphere.
Prove that because they have mountain currents that have temperature gradients going through them. Anyway, continue.
Well, yeah, maybe. I don't know. This is why I was wondering. Maybe you have a link to the thing you're referring to, but I'd be surprised if you. Oh, your mic's a little messed up.
Is that Rob?
Yeah.
Rob, are you trying to get
Anyway, Taylor, could you give me a link to there's some paper I think you referred to or whatever?
Yep, there's 3.
Yeah, we can hear you now, Rob.
Right. Yep.
Oh, okay. I've seen that, but that's different, of course.
Well, I think it gives more verification of the actual position if we can measure it blocking something else. Don't you? What do you think?
Right. Hence the celestial theodolite.
Well, it's actually good that he did the measurements at night too, because one of the 3 papers I just posted talks about how the temperature gradients will actually level out at night. And things will,
He
that's what
didn't
things
measure
like.
anything at night, did he? Didn't it?
Yeah,
There
he's
was
looking
no.
at.
Yeah, he measured the timing. A star wasn't visible anymore.
Yeah, no, but he
Yeah.
didn't measure the angle at night, though.
Yeah, he
Yes, he
did.
did with the telescope.
No, the telescope
the
isn't.
theodolite?
No. Measured it with
He
the
timed his
timing.
star,
Measured it with the
right?
timing. The star wasn't visible anymore. Oh, you
Right,
mean like he
using
watched
his
it through?
The angle at
using
night.
Yeah. Oh,
using
yeah.
his
I got.
telescope.
Yeah, I
Yeah.
got you. Yeah, that the intersection timing completes the angle, so that is the measurement. If you disagree with that, then you're disagree with basically how all of astronomy works with the occlusion timings and all their astronomical observations, where they use the same occlusion timing methodology to determine things. So if that's suddenly not valid anymore, then like I guess we can just throw out all of that.
Wow,
But
that's crazy.
you would agree, wouldn't you, Alan, that when he was looking at the star at night, he was looking at the peak. When it was occluded, he was looking directly at the peak.
Yeah.
Good.
Yeah, and you know
Hey,
what
Alan,
else
I got
is super important, real quick, Mister, before we move on, right? We're not concerned with any other time than where the star isn't. And the references that we're using is where Stellarium says the star has a true position, right? Even though the star will be observed at different locations for observers relative to their position and refractive conditions when you have a direct line of sight to it, right? But miraculously, for some unknown reason to us, right, it disappears at that same time with the same angle relationship for an observer 50.7 kilometers away, such that the elevation of the mountain is occluding the star to complete it at that same time. That's all we're concerned about, ladies and gentlemen. The relationship at that specific time to complete that angle. Where the star is on top of the peak in reference to where you could see it in refraction, none of that matters. The specific purpose of this, right, as Taylor just went over with all the different variables and changes that can be made throughout the day and the night, right? The significance of this, which was agreed upon, the best way to test it was when something gets physically blocked, when we can no longer see it anymore. So why are we making the time when this isn't seeable anymore about locations that aren't relevant to the measurement?
So I should be able to reproduce this with any occlusion, right? It doesn't matter.
Yes.
Yes, more people do it, please. That's why I'm doing this. So more people get mad and start doing it
You mentioned
themselves.
you tried doing it with a building, or you thought about doing it with a building. There's
Building.
no reason.
I tried to calculate it.
Apply, right?
Yeah, I tried it. Well, I tried to calculate it for a building earlier, and the angle to the horizon is going to be less than 1 degree. And I don't think anyone wants to try and make, like if you want to try and do that, like I'm not going to stop you, but and I could only get like 5 kilometers away and maintain that relationship, and that was with a building at 500 meters. So, or no, I'm sorry, 100 meters. Sorry.
It'd have to be a huge building, like a huge
Or
building.
you get closer, right? You get closer.
Sure, but then wouldn't that offset the relationship between like the difference between the globe and flat Earth predictions? If it works out and it's still like a significant distance, then or variable, then yeah, I'm down.
Well,
Just
if
the
the
way I
Earth
looked
is
at it.
flat and
Yeah.
refraction isn't a thing or a problem, then it
Uh-huh.
shouldn't matter how big your triangle is, provided it's big enough that the errors in the measurement of your triangle are small. So I should be able to, for example, I've got two stars, bright stars. I'm in the southern hemisphere, Cirrus
Mhm.
and Canopus. Both are like 60 or 70 degrees in the sky. So I should be able to find somewhere on my house where a feature of my house will occlude those stars at a certain point from somewhere in my yard. And I'll be able to make a
Mm.
triangle and I'll be able to measure it within a few millimeters, right? So I should be able to get an angular measurement at least as good as the one you have. And it should match what
So
Stellarium says, right?
So that's the thing though, right? Like it would be the curvature between where you're standing and where your house is occluding it. So you're going to have a small theodolite. So the timing difference between based on the curvature between those locations isn't going to be enough. I don't think significantly to make your measurement meaningful. I don't think that's.
It won't show the discrepancy.
Yeah, because think about this for a mountain that's 400 meters tall, like 4,300 meters in elevation, it comes out to be 222. Actually, let's just do 222. It comes out to be 222, right? And at 50 kilometers away, it's only 2 degrees and 31 arc minutes off the horizon. And then when you do the globe difference, it's only different by 200 meters. So it's like,
so you want to get things above the horizon anyway. That's the aim of the game, right? Because we know refraction, things their angular position changes with time.
No, I understand
as
that.
they get to the horizon. Yeah.
Right.
So, well, in that case, then if I had a relatively nearby mountain where I could get the same occlusion, or even a hill, I still don't understand why the size of my triangle, provided its precision is high enough, makes any difference. Because if you measure that angle at the triangle at the time of occlusion and compare it to Stellarium, that's the aim of the game, right? Because you guys,
But the distance
The
between
base,
you and
yeah,
the crosshair
the
is so
timing,
small and insignificant.
yeah, the timing distance isn't going to be like it's going to be negligible for both. Like I wouldn't accept it from that distance. So it's negligible.
are you saying? You mean you want me to measure from the roof of the house and the ground? Yeah, I get you.
No, 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 it's not what I'm
No.
saying. No, I'm no.
That's the 2
I'm
points of your
listen,
measurement, yeah.
listen. I'm saying that
Why do
the
people do this?
dude, that's so fucking annoying.
So weird, bro.
The
Just use a
timing,
mountain peak.
the timing, no, just timing offset isn't going to be significant enough. We're doing like with an error margin of plus or minus 1 second, right? At that distance, it's not going to. You're not going to be able to definitively tell the difference. That's why over the larger distance, it's like the difference between the globe and the flat Earth prediction is 15 to 18 arc second or actual seconds. Like in time, like in timing wise, that's the significance of it.
Yeah, it's like 12 to 16 seconds or something like that, right?
Yezo, what up?
What's up?
I have a suggestion that will.
Hey, Alan, real quick, because that whole well poisoning thing. Am I wrong in thinking that didn't Dr. Mike do this experiment prior to being in line with the flat Earth? Didn't he do this and then come to the conclusion that it was a flat Earth? So
he started as a globularist trying to help Taylor.
So he thought when it was said, "Oh, he did this and didn't like what he saw," that was inaccurate and quite literally just poisoning the well, correct?
Yeah. Yes. Absolutely.
And a gross assumption. Okay, cool. Just wanted to clarify.
That's second measurement accurately.
Yes. So I've got one quick question if I can before I go.
Mm-hmm.
So when did he actually measure 231 to Pikes Peak?
Ooh, great question. When the star was no longer visible at 6 p.m., 25 minutes, and yeah, his instrument was his camera that he was taking time lapse footage with, and the timing.
No.
Yeah.
When did he physically measure the angle?
You don't like you don't like triangles now? Are you?
No. When did he physically measure the angle? That's all I need to know.
Yeah.
So
physically measure.
are they still missing the point that the observation is about a timing and not a visual angle?
Well, why don't you just answer the question?
So the entire point of the observation is that if you use a theodolite to measure an angle, it's going, like whatever angle it's apparently at is going to be subject to optical properties that are going to be variable. So in order to not have to deal with any of that, you simply use a physical mountain blocking the star. And whatever time that the star is blocked, we know that that's where it is. So then if you go to the mountain at that time, you can see what the raw angle to the star is. And it just so happens that that raw angle to the star from the mountain at that time is the same angle as the angle to the mountain from the house using a flat baseline, meaning you have one straight line from house to mountain to star.
We understand your thing.
That's actually from the Nautical Almanac of 231. Oh, okay. So to answer your question, I just said we use the Nautical Almanac. So if you have two options, hold on. You can either say, I don't believe the Nautical Almanac is correct, or you can say, I believe the Nautical Almanac is correct, and I will treat it as valid for measurement.
I'll answer the question. He measured it with his transit. It was 2 degrees 30 minutes, and then he got a better theodolite, and it was 2 degrees 18 minutes. That's the answer to the question that you're dancing around.
What?
No,
was he
talking
not
about on the mountain?
He was talking about at night, wasn't he?
Well,
It
at
didn't
any
say
time,
during the day.
at any time, when did you measure 230 to the mountain from the observation point?
Oh, my
So
bad. Dude, well, hold on
that's
1 second. I didn't mean to be dancing around that. I thought you were talking about the measurement that was made with the occlusion. You're asking for the physical theodolite measurement. That was done
Yeah.
like he said with the transit level that gave 231 for the flat Earth prediction, and then he measured it again and it gave 219. So the measurement is in
Just what
contention here.
Stellarium predicts, right? Yeah.
Well, it's what the globe predicts. But go ahead.
Yeah. And it's also what Stellarium predicted for the angle as well at the observation site.
Oh, Stellarium
More or
doesn't
less.
predict elevation angles to mountains like that.
No. But the occlusion site at the time of the occlusion, Stellarium was predicting 231. Is that
Oh,
right? From the observation point at Ephron's place.
no,
yes.
from the mountaintop.
No.
Well, yeah, I'm sorry, from the mountain.
Okay.
But where it was
Yeah.
measured,
So
that's
Stellarium
where it
predicted
matches
231
up.
at the mountaintop and 219 at his house at the same time.
Mm-hmm.
And we measured 219 from his house with a better instrument.
Nope.
I think that you're not understanding that the instrument that we're using to measure the angle to the star is the mountain.
That wasn't the question that he was asking.
Okay, but that's what I'm telling you. Him he's not understanding. Like you're acting as if the only thing I'm allowed to talk about is your fallacious questions, right? Like you're missing the point with your questions.
Questions aren't.
No, I think you're missing. Yeah. Yeah, because
you're showing a fundamental lack of understanding of the point of the experiment.
We
you have a
understand your
proposed
point.
geometry,
can I
right?
propose something that will end the entire thing? Can I propose something? Right.
I want you to be able to steel man our position because you haven't done that in 2 separate presentations combined. You haven't got one steel man in 2 presentations. So this is the third one. So
yeah, so
at third time's the charm.
Taylor brought up the hospital paper, right, which shows that the apparent elevation of a hospital rose, right, during the night. I agree. But what Taylor didn't say is how much it rises, right? So let's say the angle during the daytime is 2 degrees 18 minutes.
Doesn't sound like a steel man.
Doesn't.
I'm laying out a proposal. I'm not answering your steel man yet. The proposal is that Mike take a time lapse starting in the daytime when the angle is 218. Let the time lapse go into the night when the visitor center lights are visible and see how much it changes by. I guarantee you it will be 1 or 2 arc minutes.
You know what, though? John gave a great steel man earlier and was being, good faith.
He is the only person from your side who has even been able to come close to steel man.
Ruhiv, could you steel man our argument, our position, before you make a proposal?
I've laid out the proposal. That's what I came to say. Do you have any comments on the proposal?
No, your proposal is meaningless unless you understand what our experiment was doing.
I understand your experiment.
Okay, show us that you understand.
Steel man it.
Show us that you understand it.
Put the observer somewhere where he's not. Take an angle, get Stellarium to predict an angle. What?
Put the observer somewhere where he's not.
Yes, the observer's not on the mountain. So put him on the mountain.
Oh, you're talking about using Stellarium. Okay, go ahead.
Yeah, so put him on the mountain, right, where he's not. Get an unrefracted angle, right, to 233, whatever it is, and just draw a straight line and assume a flat Earth back to the observer. We understand, right? We understand. It's bullshit, but we understand.
Okay, so if it's BS, how is it possible that the timing matched?
Well, I've got Alan in chat agreeing that the globe predicts a 219 height for the mountain and a 219 star occlusion from his house. That's
just a cosmic coincidence, Piezo.
Well, check Jesse.
Actually, there's a differential there of about 2 arc minutes, or 2 to 4 arc minutes, depending on how you're calculating your stuff. They're not. There's a 221 for the star, and then a 18 or 19 for the mountain.
The mountain's 219. The star. So I actually discovered this bug in Stellarium. Is it doesn't correctly account for refraction when you change the elevation of the observer. So you've got to do a workaround. All right, so the correct elevation for the star with refraction is about 218 and a half. Cool. So there's your steel man, right?
So hold on. Wait. So let me get this straight. Are you suggesting, because you still haven't answered how it's possible that his observation matched the timing for a flat baseline. Are you suggesting that the reason that if he uses a flat baseline, it makes the angle to the mountain 231, and that if he goes to the time it was occluded from his house to the mountain, the raw angle to the star from the mountain is 231? The fact that the reason that those angles match and can be treated as a straight line using a flat baseline is a coincidence?
Yes, and Jesse has pointed that out in the chat. Literally 3
Okay,
minutes
so,
ago.
so hold on, You think that Dr. Mike just happens to be so lucky and fortunate that he picked the house in the correct subdivision, in the correct neighborhood, and the correct mountain at the correct distance at the correct time and the correct star, just such that it would just so happen to create the correct atmospheric conditions and refractive indexes necessary to look like it's flat?
No.
In this one instance?
Coincidence is distance and delta height. That's the only coincidence.
Gotcha. But there's an infinite possible combination of those different deltas, and so he just got the single one that would work to make it look flat.
Yeah, that's why we're asking.
And he just happens to live there.
Yeah, we're asking for the Blodgett peak data. But he.
What do you mean? He's given that already.
He's given that
time-stamped images.
Yeah, they want the time-stamped images and our footage, which I think is a reasonable request, honestly.
Yeah. Anyway, my proposal is to show that the elevation of Pikes Peak hardly changes. It'll change by 1 or 2 arc minutes between day and night. That would destroy it, right? Do we agree that would destroy it?
What would destroy what? What are you talking about?
Your argument. It would show that
no one's
219.
No one is contesting the fact that optically it appears at 219 with the Theodolite. We don't care about that. Like, are you missing that?
Oh, really?
Did you miss that?
I did miss that. I'm glad to have that on record.
When you take a
hold on, real quick, buddy John. Why are you acting surprised? That's literally been the point of this entire discussion. That's the point. What? No, we just talked about it on Ether Cause before we went live here.
Bad, maybe.
Yeah, dude, you're bad for real bad.
I'll be honest, I missed that too.
Yeah, but
yeah. So
you're pointed at 231, the Theodolite, or the.
No, that's what I'm telling you. You have missed the point. That's why it's important for us to steelman one another and go over it like really, really meticulously. For some reason, it's so hard to understand for your group of people. Look, what do you mean? If it wasn't hard to understand, you'd understand it, right? So, no, you don't. How are you going to tell me that you understand our experiment and we don't when you literally just failed to correctly understand? Okay, when you take the flat baseline, the plane trig angle is 231. We're not saying that is the apparent position. We're saying that that's the true position. When you look through your Theodolite at the mountain that's 2 degrees above the horizon, okay, there are all kinds of optical effects causing that to be the specific apparent position at that time, right? But that is an apparent position. Where you see it is not where it is. We don't care about where it looks like it is. We care about where it actually is. That's the point of the celestial theodolite, because only where it actually is can block the actual star where it actually is. You can't use an apparent image to block a physical object.
All right, can I respond? So Stellarium, right? We agree that Stellarium, if you will see it higher, so the apparent position is higher than its actual position, correct?
According to Stellarium for the star, yeah.
Well,
it says it's actually 204 and it's shows up as 221 or whatever.
Yeah. Do you agree that it will make it higher?
That's what they say refraction does, yeah.
Oh, geez, you're really non-committal. Anyway, you're saying the opposite for the mountain, right? You're saying that it's physically at 231, but refraction makes it 219.
I didn't say it was refraction that did it. I said optical effects.
Okay.
Because the thing is, right, is what we have found is that the difference, right, the differential between the prediction for a flat baseline and a globular baseline is precisely accounted for through the differential between the chord and the straight line distance from the globe to the plane using refraction. The refractive index literally makes up because when Mike used the celestial refractive index instead of this terrestrial one for the mountain, he got 231. Weird, right? That celestial refraction would bring the mountain exactly in line with the flat baseline.
Yeah, which way does refraction work? Which way does it move the apparent position?
No, but is that also coincidence? Are you going to say that that's a coincidence too? Okay, so we just okay.
Right.
So you guys are coincidence theorists. We simply say, oh wait, maybe the reason that we can turn refraction off and we get an actual blocked star using a flat baseline is because the flat baseline actually traces a straight line to the star.
Yeah, I've never heard them worry about this much refraction with any other globe or theodolite measurements. But whenever something's actually showing that it's physically there by blocking light, then all of a sudden they're so worried about it.
Right, but did you read what I sent you 20 minutes ago, Taylor?
Nope.
Okay, so I sent you a DM. That hospital paper, which we agree on, right, raises things by a little bit. And in that paper, it raised it by about 1 arc minute.
They only
So
tested
we're not going to see.
They only tested the pixels for the hospital data.
You know what's funny is that how do we know how much refraction there is on Earth?
Yeah, you send up weather balloons, measure the temperature, pressure, and humidity.
Oh, don't set them up for that shit.
Yeah, no, it's because when they take distance measurements, they have like an expected measurement and an actual measurement, and the deviation between expected and actual is given as refraction.
Wait, I
And
want to
you
know
do-
who calculated that though.
You do that a whole bunch of times, and then all of a sudden, oh, here's our standard refraction for Earth.
Standard refraction is
Yeah, but that's literally a post hoc.
No, it's not.
Yeah, it is, because you say we should see it here, but we actually see it here. Well, we already know that it's globular. We don't need to discuss that part. So since we already know it's globular, then the reason we're not seeing it as globular must be because of this thing called refraction. So how much refraction is there? Well, however much of a difference between what we expected to see and what we saw.
Incorrect.
That's definitionally a post hoc.
Give me a steel man of our position.
I just gave it to you.
Yeah, it's a fucking rubbish steel man. That's bullshit. We do not post hoc refraction. Refraction
Wait,
is
the guy that can't give a steel man wants a steel man? That's ridiculous. If you can't ask for a steel man when you can't steel man the argument that's being laid out.
Well, his position is that Dr. Mike just so happens to live. He just coincidentally lives at the exact right distance based on the height of that mountain for it to cause it to appear flat. Right. Any other distance that he lived from that mountain wouldn't work that way. But he just so happens to live. He just happens to live at the right house.
He's been asked like 3-4 times that this presentation has gone on to steel man the argument, and he still has yet to do it. And yet he has the nerve to ask you for a steel man. It's ridiculous.
Did you say I didn't give a steel man?
Oh, I spoke over him. Right.
So Ruhit, you just said it's a coincidence, and it just happens to be a coincidence that he's at that. Okay. Wow. Okay.
Can I ask a question?
Coincidence there's, bro.
Hey, I want to ask a question because I've been listening for a while and I've been hearing
What up,
a lot
Indio?
of. Yeah, what's up? And yeah, you do assume a goal for refraction because you're assuming
No, you don't.
Yeah, you're assuming a spherically symmetric atmosphere, right?
I do not assume a globe.
You do not assume a spherically
You
symmetric
understand.
atmosphere through which the ray passes.
No, in fact.
So
most
your
refraction
gradient isn't
calculations-
radial.
Listen to what I'm saying, Indio. Most, like when you're looking at a decent altitude, most calculations for refraction actually assume a flat atmosphere. Would that blow your mind?
Yeah.
Based on what?
Who cares? We're not talking about observations
What do
from
you mean a
altitude
flat
now, are we? So you have to move the goalpost to something we're
No,
not
I
even
need to
talking
move
about.
this.
Anyway, that's not my question. Now, the timing that was measured matches the flat Earth prediction. Now, you said it could be refraction. You're using the frickin' true position. The mountain could be refracted up. Plus, it drops down because of the curvature of the Earth. So, using whatever variables you think are appropriate, does it match the time? Yes or no?
Does it match the globe timing?
Does it match the time that the mountain was measured to be, the star was measured to be occluded? Can you fiddle with the variables to get it to match that time?
The globe matches the timing, yes. It's predicted by the globe.
That it would
It's
be
off by like
occluded
2
at
arc
the
minutes.
exact same time.
Yes.
It's off by
The
2 to 4
exact-
arc minutes in Stellarium, according to Stellarium.
We went through this, right?
Yeah.
Maybe you weren't here, right? There's a
I'm
bug in
going to ask
Stellarium.
you again. The exact same time. Don't tell me about angles. Okay,
Yes,
can you
the
show
time
us?
is predicted by Stellarium, yes.
And
Can
the
you
fact
show
that we
us?
don't have to use refraction, because you said you can't use Stellarium's values because Stellarium has bugged values, so you don't even count Stellarium. You say Stellarium's wrong. We use Stellarium, which is accepted worldwide, and we turn refraction off, and we say, give us the true position of the star on the mountain according to the Nautical Almanac, and it works for the same angle to the mountain from the house using plain trig at that
We
time.
understand the 50th time that you've laid out this coincidence. We understand.
Uh-huh.
Okay.
Okay.
So at what
So
time is the mountain occluded by the globe prediction?
6:27:25, the time that it's actually occluded.
Okay, and what are the variables that are in that?
All right, so the bug in Stellarium, right? When you
Oh,
gain
now there's a bug.
altitude,
Forget it. Forget it.
well,
Now, like, we got the
listen,
super
do you want to
correction,
listen or
right?
not, India?
Bad
Do you want to listen or
programming.
not? Do you want to understand or do you want to be in your delusion for the next 20 years, Indio?
Yeah, what delusion? No, you guys are just a bunch of cope.
Okay,
They
so
use the
there's a
nautical
bug in
almanac.
Stellarium.
Yes, because when they found out that Stellarium predicted.
Forget Stellarium. What does the nautical almanac say?
I'm asking you. Oh, hang on one sec.
What is the nautical almanac? We don't have to make the corrections, right? Because we just use the nautical almanac. We don't have to worry about Stellarium. What does the nautical almanac say?
Okay, when you
That's what they use, right?
When you gain elevation above the ground and you look horizontally, you are looking through less atmosphere than you would be if you're on the ground. Do you agree with that? Okay.
Yeah, and
Stellarium does not change the amount of refraction as you gain elevation. You have to do it manually. That's a bug.
Okay, great. So let's use a nautical almanac. Forget the bug. What's the nautical almanac say?
Without refraction, well, nautical almanac tells you not to take angles to stars below 10. Without refraction, it's 206, I think.
Okay.
From not the
I want
mountain
the
peak.
timing.
From
This
the
is
house.
about timing. See, you guys always you keep this is the problem I'm having. You keep trying to interject angles into a timing argument.
So
He's trying to claim the timing would be the same for both models.
No.
Yeah, and I'd like to see that like substantiated, dude. Like seriously. You're not even going to use the same models for refraction for the mountain and the star.
Say again?
You're not going to use the same model of refraction for the mountain and the star.
Yeah, that's the second coincidence, Indio. The mountain just happens coincidentally to be the magical midpoint at which there's an instantaneous change in refractive index that causes it to bend differently at that point to line up with the observer for 231.
You understand in our model that the light from the star is traveling through the entirety of the atmosphere. You understand that's our model, correct?
Yeah, but the model itself is based upon air mass. It's not based upon what you would model refraction for a mountain.
Well, they calculate how many air masses you're looking through purely to, downgrade.
Yeah, are they equivalent?
An air mass is one.
No. Are the models that the one you would apply to the mountain and the one you'd apply to the star, are they mathematically equivalent?
Well, I'll say yes. Yeah.
No, they're way different.
You're just guessing, dude. You just
No,
guessing.
if I take Bennett's celestial formula and shorten it to 50 kilometers, it'll give the same answer.
No, actually, it doesn't give the same answer because last time you were in our server on AE, I told you that he used celestial refraction for the mountain, and you're like, why would you do that? That's wrong.
Right, because it's 50 kilometers away.
But you just now said 5 seconds ago that if you did it, it came out the same. Literally 10 seconds ago.
Shorten the distance to 50 kilometers.
He used 50 kilometers. He used it for the mountain.
Right.
And you said before that was wrong.
What would be the difference in air mass between the star observation prediction?
Oh, dude, hold on. Don't let him run away. He literally said it was wrong before. Now he's saying it's normal. And then he's saying, but it's only at 50 kilometers. But that was the original thing to begin with. We never said that the mountain was anything different than 50 kilometers. Did the mountain teleport? Like, it's always been
50 kilometers away, right?
Yeah.
It should be just one refraction calculation.
Why would you apply the amount of refraction as if the light's going through the entire atmosphere to something that's 50 kilometers away?
It doesn't
the same optical corridor.
It doesn't even matter. Listen, and it doesn't even matter because it gives the exact same prediction that you do. We just got there a slightly different way. So if either way we cut the cake, we still got there, and it still makes the same geometric predictions. So even though you don't like let's just replace how we got here with how you got there, and then now when we still get to the top of this peak, we have to change the position of the star as well. And that's what Mike wasn't doing that's what John wasn't doing in his PDF, in his picture, when he was trying to use the almanac true position with respect to the mountain peak instead of the refracted position of the star with the house, like he was trying to assert. Like, you guys have to do this all ass backwards to try and steal our timing measurement. You predict this peak being physically lower, different time. Indio is spot on talking about the timing significance. Yes, your timing does not. No, listen.
Yes, you are. I predict
listen, Ruhif. What do you predict? What do you predict that the true position of the star will be at 231 at that time that it gets intersected for the observer 50.7 kilometers away for the true position of the star? Because that's what we're measuring the timing off of. That's what intersects with the mountain peak that makes it go bye-bye for us 50.7 kilometers away. That's what we're measuring. I don't know what you're doing, but that's what we're doing.
Oh, his is 221, bro.
No, it's 218.5 because of the bug in Stellarium. Right?
Okay. That's fine.
So not 231.
That's fine.
Can I ask a question?
One second. One second before you do. Okay. 1 second. No. So a measurement though that isn't 231, right? Still significantly different timing wise. You don't have the same true position relationship and timing that we do to complete this triangle. The only reason this works with respect to the true position is because it's a flat Earth baseline, and the elevation of that mountain is actually 222 meters with respect, or 274 meters with respect to an observer 50.7 kilometers away. That's the only way it works. If the mountain was actually the daytime measurement, the timing would be different, and you wouldn't have to obfuscate.
We agree that the daytime measurement is where you actually point the theodolite, right? But what happens at nighttime? Do you have to point it higher?
What happens at nighttime is a star intersects with a mountain that corresponds to a specific time to show an angle relationship that was derived from observing the mountain from 50.7 kilometers away that just so happens to coincidentally intersect with a celestial object in the sky, so-called true position.
Right. So if we're at
the refracted position does not give the correct angle alignment for the straight line. Only the true position on the mountain gives the correct angle. So if we turn refraction on in our model, it doesn't work. But if we leave it off, it works perfectly.
Question, which wasn't answered, right? From Mike's house during the day, let's say it's 2:19, and it's looking at the visitor center. We don't care about the star yet. Looking at the visitor center, it's at 2:19. At nighttime, do I need to point the telescope to 231 to see the visitor center?
You never did to begin with.
Just answer the question, someone.
No, you don't need to point it at 231 to see it.
Okay, so I'm seeing the occlusion
Why?
happen at 219, correct?
As an apparent position, you are looking at the occlusion happen at 219. We care about the timing, though.
Yes. So at 18, 27, 25, we're looking at 219 to see it occluded, correct?
At 18, 27, 25, the apparent position is 219, not the true position. Okay, hey, hold on. Is 219? Wait. You answer my question now. Is 219 the true position? Yes or no of the star?
No, it's the geometric.
Okay, thank you. Exactly. Okay, so we don't care about, you don't care about it either. So then why are you trying to pin it on us? Like, oh, look, you're pointing at 219 when you don't think it's the true position either. It's a non-point, non-sequiter.
Because it's what we see. Like we're using
right. It's apparent. It's apparent, Ruhif. That's the point. You're laughing because you know.
I got to clip that out.
Yeah. So hey, could I want to get?
Sure, you clip the full bit.
So what is the greater? So you said, hey, the timing matches the goal prediction. Is the drop due to the curvature of the Earth? What is the drop after the refraction correction from the curvature of the Earth?
To 200 meters drop.
And what is that angle? What would be the angle to the top of the mountain?
Without refraction is
217. Did you not listen? Okay, I said calculate the drop, then add back the drop some of the drop that you dropped the mountain. Then you add a refraction correction, you lift the mountain back up. Yep. What's that angle?
219. That's our globe prediction for what we should measure optically.
Okay, so it can't possibly match the same time.
It
It's
does
not the same
match.
value. It's not the same value. How can it be the same time?
Right, the Stellarium prediction for your occlusion is 218 and a half.
Because listen, the star's only going to be lifted up. So now the star's going to be higher. So your
That's
mountain's
not the
too high,
Stellarium
and then
prediction.
the star's going to be higher even than the mountain, right?
You literally said Stellarium had a bug, so it's not the Stellarium prediction.
No, I've accounted for the bug, and the Stellarium prediction is 218.
Oh, so no, that's not Stellarium. That's your prediction, right? Because Stellarium's would be what it actually says on the computer screen, right?
Look, it's really simple. Though. There's no way the star could be occluded at that time. It's not possible.
Did you listen to the explanation of the bug, Pizzo?
Yeah, 1 second.
Yeah,
Pizzo.
but you just said you corrected for the bug.
1 second.
And the value you gave is different than the value that they have.
218 and a half versus 219.
His correction's fine.
Yeah, 218 and a half. Yeah, but it's still a different time. It can't possibly be the same time. But when you add in the fact that the star with refraction also has to be lifted up. So the star has to come down to occlude the mountaintop. But if the star's higher, it takes longer, has a longer visual distance to go down, right? It can't possibly be the same time.
Indio, just to be clear, the sole reason that Ruhif went to go try and
you want Ruhif, dude, substantiate it this the same time for real.
The entire reason that Ruhif.
No, I don't want a screenshot. I want you to substantiate.
Went in the first place to go and try and check on this apparent bug, which we're just like, I'm not saying he's wrong. I don't know. But like, we're just taking him at his word at this point. But the only reason he went in the first place to go, quote unquote, look and check it is because he realized that there was a different timing or a different angle at that time. And he's like, oh, that shouldn't be the case because I know Glob is right. So that's weird. Huh? How can they be right and I'm wrong? So that's the only reason in the first place he went to go check Stellarium. But if that's the case, okay. If that's the case, then when we go to any other location, such as Blodgett Peak, and we do the same thing, that bug's still there, so there should be another differential. So it would be super weird if it worked at more than one location, right?
Yeah, we're waiting for the data for the Blodgett Peak, but isn't it interesting that me knowing that the Earth is a globe led me to discover a bug? Is that interesting?
Yeah, cool story. You probably just like
you
were looking for outs and just combed the forums, dude. It's not, you didn't discover anything. It's a well-known bug. McToon knew about it. He told me about it over a year ago. So you're full of shit.
Ruhif told me about it.
So if McToon knows about it, he's a fucking sped.
Well, either way,
you certainly knew about it.
Yeah. I mean,
either way, we're dealing with the physical intersection point that corresponds to the so-called true position, eliminating any apparent position shenanigans. Go ahead and continue, lads.
The timing has to be different because. Hold on.
Yeah, go ahead.
The timing has to be different because what Ruhif is using as the occlusion timing is the refracted position of these objects, not the true position. And they are blocked at their true position.
Can I just say, there's been a lot of getting me to successfully, I think Ruhif and I both can tell you in detail what your method involves doing. And I did. I've done it twice now. I get the sense when you talk about us not being able to do it ourselves, it strikes me that that's a suggestion that you can't steelman our position, which I think is pretty simple.
I didn't say that about you, John. I said about
Ruhif. It doesn't even matter what your position is. The only position you can have that possibly matters.
Hold on, Indio. Hold on. Let him finish.
Hold on. Let me just finish. Our method is pretty simple. I think you find a star that's going to be occluded, and you measure the time that the occlusion is, and you ask Stellarium how high the star was at that time. That's it. That's the entire method.
Yeah, we know. And then you add, the bug correction or whatever. Anyways, the point is, John, is even in the case where Ruhif lives in this world where Dr. Mike just so happens to live at the one location relative to this mountain where it would match up to a flat baseline, and it's just this circumstantial, serendipitous, divine intervention coincidence that happened, right? Because that's in Ruhif's world, that's what happened, right?
Well, it's not what happened. It's not what I think happened. I've already explained what I think happened.
Even if that was the case, though, it's still a problem because you guys are using the refracted position of the mountain to occlude the refracted position of the star. We are claiming that the true position is what gets occluded.
Right, I get that you're claiming that, but the claim that has merit is the one that has the light following the path that the light actually follows.
You have no idea if that's the way it actually follows.
Yeah, that's the point. Yeah, y'all are making that claim baselessly. You're claiming that's the way it actually follows. Says who? Independently, how do you make that claim, right?
Stellarium
without
Stellarium
reification.
Listen, if it's refracted, if it's refracted, then we would still see it. So we all agree that you said earlier the best way to test. You said the best way earlier to test refraction is when something's physically occluded. So we have this thing, this so-called. So we have this so-called true position of this thing, right? And we have this calculated elevation of what we're asserting from our observation point is a physical object, and that corresponds to it having an angle of 231 from the observer to the peak of that mountain. And then coincidentally, right, the so-called true position of this star intersects at that peak at the same time, at that same angle, and suddenly the observer 50.7 kilometers away can't see the starlight anymore. So we know that whatever it is, right? Whatever the star is being physically occluded at that time by a physical object that corresponds to a specific elevation angle that also corresponds to a specific distance to derive that angle.
Correct. And Alan, the point that's so beautiful, Alan just said, and I just realized I hadn't been specific enough in this like little tiny detail, right? The true position in your model of the mountain is 217. Okay. The refracted position of the mountain is 219, and the refracted position of the star is 219. So that's how you guys say that it lines up. But wait, so if the star is at 219 optically, but the mountain is at 217 physically, it would not occlude it. And a refracted image of a mountain will not occlude a star. Only a physical mountain will occlude the star.
Well, it's the physical mountain. It's the physical mountain that's occluding the star, and both the physical mountain and the star are being refracted upward.
We would still see the star if it wasn't being blocked by the physical mountain. If the star is at 219, no, it's not. Sorry. If the star is at 219, then it's above the mountain because the mountain's at 217.
No, it's not, because
yes, it is. 219 is a higher angle.
At 219.
No,
the physical star. The starlight and the top of the mountain are at 217.7 when the starlight passes the mountain. But then all of that light curves downward so that we see both the mountaintop and the star at the instant that it's being occluded.
No.
219.
The star is at no. The star's refracted position is somewhere between 219 and 221, bug or no bug. Either way, it's 2 to 4. It's 2 to 4 arc. Yeah. Ruhif just said it, bro. He just said after he did the correction, it was 219. 221 is what Stellarium says. After you take the bug out, it's 219. That's been this whole night. I mean, it's on record. We can go back and listen to it if you want to contest it.
219. That's what it is. It's
but the mountain isn't physically true position at 217, which means the light from the star, don't interrupt me, the light from the star is coming in above the physical mountain. Hold on. A mountain, okay, if this mountain is truly at 217, and the apparent position of the star is at 219. I don't care if this mountain's getting refracted to 350. It's still not going to block the mountain because a mountainous mirage will not block the star.
Wow. The star gets occluded by the peak. Yeah.
Does it get occluded by the physical peak? Wait. Does it get occluded by the physical peak or the refracted peak?
The star gets occluded by the physical peak, and then the whole thing, the peak and the star, get refracted because we're seeing both of them. They're
it's not
both
possible, John.
refracted upward.
John, I don't think you understand what you're saying.
You just said the
true
physical
position
mountain
of the star is being blocked by the mirage position of the mountain.
No, that's not what he's saying.
No, he's saying that the apparent
that's
position.
what you're saying, isn't it? Isn't that
No,
what you're
the
saying?
apparent in their model, the apparent position of the star is at 219. So the light is being bent and it's coming to us at an angle of 219, right? Where we see the star, the light stream is coming in at 219.
What's the true position?
Well, it's like 204. But the light stream in their model is being bent and coming to us at 219. But there's this mountain in between us that is physically at 217. So their claim has to be that mountain's getting refracted up. It's getting, an apparent position is causing it to rise up to 219. And that the apparent mirage of the mountain is blocking the starlight. That has to be their position.
That's not
the physical mountain's not blocking it, bro, because 219 is higher than 217. 19 is a bigger number than 17.
This is hard to
Physical mountain. Yeah, go ahead, Rui, you do it.
Can you see the diagram I posted at 48 minutes past?
40. 1 second.
Yes, I posted 2. Just check the first one. In fact, you can do a little blink test between them.
Okay, I see the 2 images.
Cool. Okay, so the path of light from the star is curved. All right, and the angle, so that's the yellow line. The angle at which that light comes into your eye is 219, right? 219 is the red line. Cool? That's where we see it. That's its apparent position. Can you see if you flick to the next one that the curved path gets blocked by the mountain? You're still looking at 219, but you've gone 1 second later, it's blocked. So I can't share screen, can I? 1 sec.
Yeah, but is that mountain peak drawn at 219 or 217, Ruhiv?
The physical mountain, so the yellow path, that's 217. The red path is 219.
Okay, but the starlight's not coming in at 217, so that's irrelevant. It wouldn't get blocked.
Right. Fuck.
Yeah, right. It wouldn't get blocked. It wouldn't get blocked.
I think part of the problem is not ever understanding the idea of tangent lines. I really think that's the ray of light that is just about to be blocked by the mountain at its position, its true position of 217, ends up coming into your eye at 219. And then a moment later, that ray of light is blocked, so you no longer see it at 219.
Dude,
it's really simple.
Do you say that the mountain is at 217 and it's blocking the star at 219? How does that work? It's not in front of it. It's not in between you.
Look at Ruhiv's diagram.
Bro, I looked at his diagram and I just told the star. He just said that starlight yellow stream is 217, but that's not your guys' angle prediction. Your angle prediction for the star is 219.
In Ruhiv's diagram, it's the actual mountain, though.
Yeah, it's the actual mountain, not the. He needs to draw a phantom of the mountain up to the red line.
No, you don't. He could, but he doesn't have to. Go ahead, Ruth.
Dude, the starlight is not coming in at 217, bro. It's coming in at 219. Do you see how the red line is above the mountain? That means that the mountain wouldn't block the red line. The red line is the starlight, right?
If you understand what the red line is.
The red line is the starlight.
It's a tangent to the yellow line. It's a tangent to the yellow line.
It's not touching it, bro.
The place. Well, it's meant to be a tangent to the yellow line at the point where the light is being observed, at the house. Now that light passes the mountain where the mountain is at a straight line angle of 217 and proceeds to come in because of the bending with a tangent line of 219.
Wait.
Then
Where
a
do you get the math for
moment later,
217?
hold
What you're
on.
confused about is the deceptive diagram, dude. That's what you're confused about.
Yeah. Where are you getting the math for
diagram,
217?
why isn't the tangent matching the arc of the star on
Oh,
that
we
one?
got two people back to back asking questions
So
rapid fire.
disgusting. You're
Let's just, I
you
know.
guys
Let's,
just disgust me. Like you really do. Like the
Wait
shit
a
you guys
second.
pull.
Where in the world did all of a sudden we get this third angle of 217 from now? Because now you're saying that at this magical midpoint, the star is actually coming in at 217 and it becomes 219 by the time it gets to us. Where's the math showing that? Y'all haven't substantiated that at all. It just has to be that way for it to work in your paradigm. That's the only reason you're purporting it to be true. There's no substantiation of a 217.
If you add a straight line from the house, to the mountain, that angle is 217. Okay.
And the star is 219 from the house.
So the tangent to that yellow line do you understand the tangent to the line there? The tangent to the yellow line. You understand that? I really think that's often a problem in these, is that people don't understand
I want you to
of a tangent.
draw me up the math to show me 217 and not 219, because the numbers that everywhere I've seen, Stellarium's 221, refraction bug fix is 219. There's not a single 217 anywhere. So show me the math that substantiates your 217 or get out of here, please.
Well, I'm just going to say it one more time. I really think
you saying it doesn't make it true.
Problem.
It's a tautology at this point.
Yeah, 1 second. Your repeated, you don't know what a tangent is, bro. Freaking relax on that, dog. Make an actual argument other than playing that game. Know what a tangent is.
To the mountain. That line has an angle of 217, okay? Now, if the tangent to that curved line that's about to be blocked by the mountain at its end is 219. So you're looking at the star at 219, just as the light that is curving downward to have that tangent at the end is about to be blocked by a mountain that is at 217 if you draw a straight line from it to the house.
I understood it the first 3 times, but you have yet, no one in your camp has substantiated the 2-degree differential that should be drawn on that diagram between the red line and the yellow line at the mountain peak. There should be a 2-degree differential.
Not 2 degree, 2 minute. 2 minute.
Sorry, 2 arc minute. My bad. 2 arc minute differential between that yellow line and red line at the mountain peak. There should be.
Right.
And there's no math showing that. You guys are just saying it must be so because glob. That's not an argument.
It's not about globe. This is their flat Earth or globe. The index of refraction
if it's FE,
gradient,
it's 231, bro.
No. But you get refraction. The refraction is minor. Forget about it if you want. It doesn't make any difference. If you want to just make it 217 or 219, I don't care. It's not 231. It's 217, 219.
Yeah, at 219, it wouldn't be blocked by an object at 217 because it's 2 arc minutes higher. It would take another 8 seconds. It would take an extra 8 seconds to get blocked. It'd be off by 8 seconds.
So I'm not going to go through it again. But
you don't need to. I understand perfectly.
But you wanted an explanation of where the 2 arc minutes comes from.
You're giving an arbitrary explanation with no substantiation.
No, I'm going to give you a specific. You can look up the index of refraction. You can look at the radius of curvature of light in standard atmospheres. It gets a little lower as you get up at altitude. But at the altitudes we're talking about, it's about 4 arc seconds per kilometer of curvature. Now, when a ray curves from the mountaintop down to the observer at the house, notice that at first it's kind of heading upward, and then at some point it's traveling parallel to a line straight to the mountain peak, and then it starts coming down. So if you take that 4 arc second over 50 kilometers, you get about 3.5 arc minutes of total curvature. But half of that total curvature is used to bring that ray back to parallel the line to the mountaintop. The other half causes an upward shift of the remainder, which is about 1.7, ish arc minutes. Once again, it's a minor thing. It doesn't even matter if you take it into account, but that's where it comes from.
Hold on. Is the occlusion timing in your model based on it being occluded at 217 or 219? 219, right?
It's based on the apparent star being blinking out. It's when the star will blink out at 219 because it can only blink out when it's at the same elevation as the visual mountain. If the star were lower than the visual mountain, you wouldn't see it.
It had to be lower than the physical mountain, buddy. There's a 2
If you're
arc
looking
minute.
up,
dude,
if you look up and you see a mountain that is
John, please don't
219
interrupt.
high.
John, he was just speaking.
Sorry.
Yeah,
you're right.
Good.
You're right.
You're good. You're good. I know it happens. It's all good.
There's a 2 arc minute difference between even bug fixed Stellarium, where it says that the apparent position of the star is and where the mountain is. Now look, check this out. If there wasn't a bug fix and it was still 221, but the mountain's at 217, then what you would be saying right now is, well, it comes in at 221, but it's actually still being blocked at 217. So there's a 4 arc minute difference between the red and yellow line, not a 2. And I'd say substantiate it. And you'd be like, well, if you just look into refractive indexes and how it works, you'd be able to find it. You'd be saying the same thing with no substantiation. You don't have any substantiation for saying that it's actually at 217 when all your measurements say 219 to 221.
So
I don't care if it's only 2 arc minutes or only 4 arc minutes. That's still a physical timing difference. It's 4 seconds per arc minute. He has a time lapse footage with GPS time sync. So even 1 second would be noticeable. 4 seconds is very noticeable. 8 seconds would be 2 arc minutes. So we've got anywhere between 8 and 16 seconds of differential that should be there. That's not.
Hey, Alan.
Okay, so whatever you're going to look at, when you look at the mountain, you see it at whatever it is, 221, 219, I don't care what it is, but wherever you see that mountain, you will not be able to see a star lower than that. Now you're already seeing the mountain above where it is. If the star somehow being at, say, 218.7 was above the physical mountain, but below the visual mountain, then you're actually proposing that you're going to see a mountain that's 219 high, and you're going to see a star at 218.7 shining through that visible mountain because there's not a physical mountain there to block it.
From the mountain to the house, does the light go up and then down?
Yes.
Okay. So if it has a consistent travel path, then halfway would be the highest point for the light, right?
Not highest, but the point where it's going to be traveling parallel to the direction to the mountain.
Okay. So that would mean that the midpoint between the house and the mountain should be the 219, right? Not where it is at the house.
No, the point is what the ray comes into the mountain at 215, and then it comes to 217 at the midpoint, and then by the time it gets to the house, it's at 219.
So the ray comes into the mountain at 215, even though the mountain's at 217. Interesting.
That's
so
right.
That would be blocked. It would already be blocked before that time anyway. Then.
No,
that's we would see it occluded before.
No, that's the angle at which it gets to the top. The position, when that light ray gets to the top of the mountain, it's traveling downward at 215. Then it continues to travel downward, curves to 217 so that it's traveling parallel to the line to the mountain, and then it continues to curve another 2 arc minutes so that it's curving downward at
How can it be at 215 at the mountain peak? How can it be at 215 at the mountain peak? You're double speaking, bro.
No, that's ridiculous. You can have light traveling in any direction you want at the mountain peak. Light can travel in any direction at that position. And as you can see from Ruhif's diagram, the light is traveling at a shallower angle than the angle to the house.
Is the light bending from the star to the mountain to the house? Is it bending down or bending up?
It's bending down.
Okay. So if it's at 215 already at the mountain, how would it then go to 217 and then to 219? That's bending up, bro.
Oh boy. I don't understand what you mean. I'm talking about 215 relative to horizontal, right? It's traveling downward below horizontal when it's at the peak at 215. Then it continues to travel further downward so that it's at 217 at the midpoint. And then by the time it gets to the house, it's at 219.
If it's traveling down, if it's at 215, traveling downward would be a decrease in angle, not upward.
I don't know if you don't understand what I mean. You're traveling at the angle that the ray is making. It's traveling downward, but that ray is making an angle of 2 degrees and 15 minutes to a horizontal at that point. I don't know if I have to draw a picture or something. I mean, I don't see why you can't see that from the picture that Ruhif drew. But it does require thinking about tangents, right? The intersection of a straight line with a curve.
But
you have
that would
to think
mean
about the tangent to the curve at that point.
no, but John, that would mean that if we pointed it at the mountain peak, because it would be at the mountain peak, you're now saying it would be 215, because earlier it was 217, but realizing that the midpoint would be 217, now it's 215. That would mean that if we pointed at the mountain where the light was crossing the mountain tip at 215, then the mountain physically should be at 215, and it's not. Because we can take that red line and lower it to the mountain peak, it would have to be 215, and it's not. It's 217. So you're still wrong, bro. It wouldn't make it over the mountain. It would be occluded prior to that.
I just don't understand this. The light comes down at the point that that light ray that you ultimately see, at the point that ray is crossing the mountain peak. Right
It's
at
at
the
what
mountain
angle?
peak.
What
it's
angle?
Traveling at an angle of 2 degrees and 15. That's
so if we're at the house,
it's not traveling straight toward you. If it were traveling at 217, it would be traveling straight toward you at that
okay.
point.
So if we are at the house at the moment that light crosses that mountain peak, and we point from our house, if we point at that location, what angle are we at? What angle are we pointing at?
At the mountain peak? At the mountain peak? At the apparent mountain peak, or at the true position of the mountain peak?
You just said at the moment that light comes over top of the mountain and it's pointed down at 215. I say, okay, at that point, whatever point that is, if I'm at the house and I point at that point, what is the angle of my instrument?
Well, okay, so you're going to point at a
just give me an angle.
I can't. Well, I don't know what you have to. Am I pointing at where I see the peak, or am I pointing at where the peak is?
I'm asking you to point at where the location physically is of that light as it crests that mountain peak where you just said it's traveling down at 215.
Okay, well then you would have to point at 217. But what you'd be looking at is something below the top of the mountain.
So light's coming in below the top of the mountain and then curving up and then down.
The light is coming. The light is coming to your eye from below the top of the mountain too, but the light that comes into your eye from the top of the mountain comes down at 219.
That's crazy.
Well, suck it up.
Can we point out something really quick? That
diagram
is not to scale, number one. The position of the star is not given, right? So the distance of the star. So that arc, that little yellow line that you guys are drawing is fucking stupid. Thank you very much.
Yeah, because they have a star, the light from a star.
And again, just to reiterate, the significance of this is we're using the true position of the star. We're not refracting. We have a timing that matches from 50 kilometers away based on a physical elevation angle prediction that is different from the timing that is predicted by the globe. while using apparent positions of the stars with no
So
with no timing to match. Go ahead and continue.
Yeah, at this point, they've said so. So just to be clear, their position officially is that for Pikes Peak, it was just a very, very unlucky for them, very lucky for us, coincidence that it matched a flat baseline. And for Blodgett Peak, it matched a flat baseline too. But since they don't have the pictures yet, then he must be making it up, and it's not actually true.
Yeah, I had a question. Can you go back to the other thing?
So I'm just wondering if he comes out with these timestamp pictures of Blodgett Peak and gives it to them, are they going to then say that he's lying, or is it going to be another coincidence?
Okay, so you have the timing here. It's 6:27:25, right? Is this calculated from this 231 angle, or is this where he the time?
No, this is from his time lapse footage.
So this is the time that he saw it disappear.
Yes.
Okay, so this is the visual star disappearing behind the top of the mountain.
Sure.
Okay, what does Stellarium say that angle should be? Like the true position of the star at vantage?
True position or apparent?
True.
True
230
advantage 2, right?
No, 204 on the globe is what the true position of the star is from his house at that time.
204, and it's 231 advantage 2.
Yes.
Yep.
So why are you using the apparent timing at 230? It's not even. It's the calculated one, right? At 231.
So 231 is the true position of the star from the mountaintop at that time.
Okay, so why is there a straight line here going
because
from
if
one to this astronomical object?
Great question. Because if you don't use a spherical baseline and you use a flat baseline, right, then the angle to the mountain on a flat baseline is also 231. So at the time, 627.25, that he visually saw it occluded, he knows from a flat baseline 231 is the angle to that mountain peak that is blocking the star.
So
if he then goes to
204,
because it's using a flat or a spherical baseline.
So what does it say 231 from vantage 2 then?
Because it's using a spherical baseline from the Nautical Almanac at 231.
So how come
But
that
the
one's
point
right,
is,
the other one's wrong?
right, because when you look at 231 and compare it to a flat baseline, they line up. That's the thing is we don't know
But
where
that's
whether
arbitrary.
the
Why are you keeping one and tossing out the other? Why not do 204 and see where that lines up to when the thing's at 204 from the top of the mountain?
because 204 would be if we were to be able to like cut the ground out from underneath his house to another observer at a further location away and use his house as the occluding object.
What? No, 204 is from vantage 1, right? 204 is where Stellarium says at that time you should see the star, right?
The 204 is where it says the Nautical Almanac claims the true position of the star is, and then it's being lifted up by refraction.
It's being lifted up to 231?
It's being lifted. Well, no, it's being at his house. It's being lifted from 204 to 221 or 219, according to Stellarium.
231.
Because that's the flat baseline angle using plane trig. That's the triangle. If you draw a triangle of a base 50.7 kilometers and height 2,226 meters, you get an angle of 231.
All right, this thing's a hot mess. Okay, so 231 is the height to the mountain peak, right? The calculated height to the mountain peak.
Using a plane.
Okay, using a plane, sure. So
yes.
the true angle of the star is 204, but the refracted star is at 219, right?
On a globular baseline, yes.
Okay, so why is this mountain at 231 only just blocking the 219 refracted star?
Well, because it's not actually a 219 refracted star; it's 231 from the position of the mountain. You see the difference between 231 and 204, right? Because 231 is the true position at the mountain, and 204 is the true position from his house using Stellarium. That's a 27 arc minute difference. That 27 arc minute difference just so happens to be the differential of the arc sign of the radius of Earth over the distance between the mountain and the house. So that 27 arc minute difference is what you get when you just rotate your observer point from one point to another. So in order to get rid of any of those optical effects, we just take the true position at one point and then extend that line to another point. Because if it is true, if it is a true position, right, then a straight line can be traced from it. So this is a method of forcing the line.
Okay, I'm not going to pretend like I know what you just said, but I suspect you don't know what you just said.
Who's speaking? Who was that? Hold on. What was that?
Jesus Christ, I think.
No, who?
No, that was you, man.
Oh, me.
Manufacturer.
Yeah,
Yeah,
manufacturer.
you suspect he doesn't know what he's talking about. All right. Do you have any further questions?
Yes. So it's 231, the calculated height to the mountain, and you got 231 from the mountain as the true position.
Yeah.
The time 6:27:25 is when the visible light from the star was no longer visible behind the mountain.
Yes.
What angle was the star?
231.
No, at vantage 1, I mean.
231, bro. That's what we're saying. Like, in reality, it has to be 231 because that's why the timings matched when it was occluded. That's what this shows. That's our argument.
Right. So you're saying that's the height it has to be because of your calculation.
It's not based on the calculation. We saw it disappear.
Yeah, but you're calculating 231. 231 is based on the calculation. That's the time it disappeared.
We're confirming
You're saying
our
that must be the
calculation, though.
angle at which it must have.
Yeah, we're confirming our calculation by using the star and the mountain.
The true position of the star specifically.
Yeah, the true position. So why should
but
that
the true
be
position,
the refracted position that goes behind the optical obstruction?
the true position of the star, as observed from Heffron's house, was 2 degrees and 6 minutes.
Well, the only way that timing would correspond, though, is if it actually was, though. Because Stellarium doesn't know that what Mike's house was when we did the calculations. We started with only on the peak here. That's all we started with, dog.
Yeah, you don't even have to plug Mike's house onto Stellarium. Just to be clear, the only thing you need.
No, hold on one second.
No, that's not the problem. Go ahead.
Go ahead, Piezo. No, that is the significance of this.
But you have 231, right? The true position from vantage 2. Everything to the right of vantage 2 is nonsense. Like there's no confirmation of this. The confirmation you have doesn't.
There is a confirmation.
231 at vantage 1, though.
All right, let's try. Let's work it backwards.
The Theodolite doesn't confirm. The timing doesn't seem to confirm.
The timing does confirm. It's 25 seconds. It's 6:27:25. What do you mean? That's the entire measurement is the timing.
Right, but the visual light, right? The apparent position of the star goes behind the optical obstruction.
But if it can't be an optical obstruction, it has to be a physical obstruction if it's going to block anything.
I'm not going to relitigate this. What John was trying to explain to you is absolutely correct. You don't understand how refraction or optics seem to work, but that's incorrect what you just said.
Okay, so let me just
we
to be
don't
clear.
understand. Get this guy out of here.
Yeah, just to be clear.
Again, but they went around in circles for like a half an hour. I don't know if everybody wants to listen to that.
Just to be clear, we can work this backwards and still arrive at our position. Ready? I can tell you that all I want you to do is to use Stellarium to go to any mountaintop. We'll use this one, for example, and tell me the true position to a star at a certain time.
But I don't need to do that. I can go to Vantage 1 and pull up Stellarium. It'll tell me.
No, hold on. I'm trying to explain something to you. So you don't know where my Vantage 1 is. I haven't told you. I haven't even gone there. I'm not there yet. I'm not anywhere near you, right? I don't even live in your state. You're just on a mountain, right, in Stellarium. And I say, pick a star. And you say, okay, so you pick this star, 39 Aquarii. And I say, okay, pick a time of night and use Stellarium at that particular time and tell me what the angle to that star is. and you say, okay, I'm gonna pick 627.25, and the angle to the
time.
Just arbitrarily, just pick one. It doesn't matter.
No,
Just
but you
pick
didn't. It wasn't arbitrary.
Hold on, bro. I'm not finished. I'm explaining to you right now. I'm not talking about what Mike Heffron did. I'm talking about something that we could do. I'm giving you a prediction. So you just go to that mountain in Stellarium, turn refraction off, make sure refraction's off so you're looking at true position. Pick a star, okay? Pick a star. Pick any star you want. Pick one that's, relatively low in the sky so we can get pretty far away and it'll be, obstructed by the mountain. It needs to be pretty low. But pick a star and then pick a time where that star is low. Like, let's say, between 2 and 3 degrees, something like that. Okay. And tell me at that time that you picked what the angle to the star is. All you got to do is give me the time and the angle to that star. In fact, you don't even have to give me the time. You just got to give me the angle to the star and tell me what the star is. So if you give me the star and the angle to the star, what I can do is I can then use plane trig to find out with the known angle and the known height what my base is, what my distance away is, and I can drive that I can plug in the distance and figure out what the lat long would be and drive to that lat long, set up my telescope, put a time-lapse camera on it, and then record it and get a time lapse, and on that time lapse, that star will be obstructed at the same time that you had your time. The times will match.
That's because look at my diagram at 818. That's because that line from the true position of the star will continue right down to that point you calculated, right?
Using a flat baseline.
Right. And so then the question is, if you look at that diagram, the true position of the star, the direction to the true position of the star from Mike Heffron's house is that lowest orange ray. The true position of the star is completely blocked by the mountain, according to Stellarium.
But to be clear, you guys said earlier, both you and Ruhiv said that it was only a coincidence that it happened for this one particular case. He just got lucky with his distance and height. So that means that if we use this method works for any distance and any height for any mountain. Anywhere in the world.
I just explained why it doesn't. You just look at the diagram. It is true that at the peak, the true direction to the star is 2 degrees, 132. I got 32 something there. If you draw that line backward, then that intersects the ground somewhere, Heffron's place, right? And Heffron would be also looking at the true position of the star. But the true position of the star from Heffron's place is at 2 degrees and 5 minutes. That's the direction to the true position of the star from Mike Heffron's place.
Clearly it's not, though, right?
That's what Stellarium tells you. Are we trusting Stellarium or not?
But Stellarium doesn't. We're not plugging Mike Heffron's house into Stellarium. He doesn't know where his house is. In this method I just gave you, method I just gave you, we don't say anything about Heffron's house. All we care about is the mountain.
Yeah, it's not for fuck's sake, John. It's the entire point of the argument.
Well, it doesn't match our observations.
Yeah, that's when it disappears.
Well, why are you ignoring the fact that the times matched up? In your position, that has to be a coincidence and can be nothing other than a lucky coincidence in this one particular case. Did you disagree? Do you disagree? Do you disagree? I'm the one who asked you, bro. Do you disagree that it's only a coincidence that the times matched our flat prediction?
I have evidence that it's a coincidence.
Okay, so that would mean that it wouldn't work for any other location and other distance, right? Because any other location or other distance would create a differential.
No, it doesn't mean that. It can happen at other places, but it
could, but it would be
everywhere.
It could technically happen.
I want to be clear. It doesn't happen here either. It's just that it's close. It's so close you can't tell the difference here.
You could tell the difference because the difference is based on timing. 1 arc minute is 4 seconds. His timing would be off by a perceptible amount.
Well, no, hold on. If you say it's 231 at vantage 1, right? That's the prediction. That's the calculation done off a flat plane. Then you should expect that the star is going to disappear when it's at angle 231. But apparently at vantage 1, it's at 206. So that doesn't match the
On a globe it is.
No, that's what Stellarium says, period. But the point is this. If you look at the diagram once again, the flat Earth prediction to the peak is 231. The Stellarium tells you that the star, the true position of the star, is at 232.9 or something like that. So they're close. You want to make those identical. They're not identical, and I understand as well as anybody that you never get identical, right? Those could be the same, but the fact is they're not. The only reason you're so happy with this is because they're close, and it looks like they're the same. They're not the same. They're just too close to really be able to say they're different.
No, the angle to the mountain peak is 231 with plane trig. It's not 232.9 or whatever.
If you compare your calculated, I don't care what your calculated direction to the peak is, it will not be the same thing that Stellarium gives. It'll just be close.
Yeah, that's Stellarium is not what we're using to do a triangle to the peak, bro. We just do base and height.
Yo, this is crazy, dude.
It's just a tangent function, bro. You don't need Stellarium to use tangent. Like, that's a stupid question.
You have to compare that. You're
Why don't I need
comparing
Stellarium? Dude, I have a calculator, bro. Take your calculator and do 2220 tangent 2226 over 50,700 and see what you get. Is a calculator accurate? Can this guy leave?
Is this guy asking if a calculator is accurate?
Dude,
This guy's serious?
It's negator, dog. He's best done by just negating him from the conversation and setting his mute or his volume to 0. He's a literal like 0 impact Z DPS.
Yeah, I guess every calculator in the world that gives the same exact reading for a tangent function are all simultaneously not correct in your world. Got it, bro. Well, I don't want to live in your world, so I'm going to mute you now. Yeah, okay. Now...
I think we can wrap this up.
I have one final question. Do we even need the star for this? Because if the flat Earth prediction is simply that from vantage 1, the mountaintop is at 231, and the globe predicts it's at 218, 219, can't we just measure that?
It's wild that they still don't comprehend that apparent does not equal actual. Like, why can't we just take an apparent measurement and treat that as actual and say it's not right? Dude, how about this? I want to know John's position and, Ruhiv's position, because they have all, and also Jesse did the same thing. They have all claimed that it was a coincidence that it worked out in our favor this time. We also have the data from Blodgett Peak. It also worked out in our favor. Now they are claiming that, well, we don't have the pictures with the timestamps on the photos yet, so we want that. But I want to know, since you're asking that question, please make your position clear. Is your position that Mike Heffron is lying about those measurements and that the Blodgett Peak is falsified? Because if that's not your position, then why are you so adamant about needing the timestamp photos before you believe it? Please tell me.
I'll make my position clear. Number one, I believe that it's a little bit of a coincidence in the case of Pikes Peak. Some of that coincidence is explained by the fact that the angles, while they aren't the same. They literally aren't the same. They're close, and they're close enough for me. I would say, yeah, those could be the same, but they aren't the same. I know that, just physically. So that's part of it. As far as is Mike Heffron lying, I actually don't know. I sent Ruhi some
Blodgett
data
Peak, bro.
that I got from him today. This isn't Blodgett Peak. This is another thing.
I'm
But
asking
this
about
is some
Blodgett Peak.
very so. I will say I'm a little suspicious. I don't think he was lying about Pikes Peak. But the data I sent Ruhi today is very peculiar.
What
and I
about
don't
Blodgett
see
Peak?
any other explanation. Blodgett Peak, I don't know, but I think it's possible given the fact of this other data that I sent Ruhi. And at some point, I'll make that public as well.
Okay, so what does that mean? What data are you talking about? So basically, you're saying
This is data that I think this is data that he used to calibrate his Sokia Theodolite.
What?
And the data has
all
a
we care about,
Dude, what the ruck?
all we care about is the time, bro.
I'll put it. I'll put
Yo.
the data in the chat. I'll put the data in the chat.
Your contention to the Blodgett Peak isn't the timing of star occlusions?
Say again.
Your contention to Blodgett Peak isn't the star timing occlusions?
Well, I think there's something funny about the Blodgett Peak data.
What's funny
but I'm
about
not
it?
prepared to
What's
say.
funny about it? What's funny about it?
Right. That's what's actually
Well, no,
clinically insane
what I
about the
was,
situation.
but what I was just talking about, what I was just talking about is theodolite measurements. I'm talking about something else now, and I'll put
none of us are.
If you keep up with the conversation, those measurements are what's in contention. We don't care or dispute them. We're trying to figure out about your contentions with our current methodology.
Which is about timing of occlusion.
Which is about timing occlusion, and you said you have something that you're not ready to make public. But I mean, what does that?
Well, I will make it public. I'll put the data up, but I don't know. I think Rudy will be able to see what.
Is it occlusion timing?
Can you articulate?
Is it occlusion timing? You just said it was theodolite stuff. So if it's theodolite stuff, I don't think anyone's going to care because that's not our point in the first place. You've missed the entire point.
No, I agree, but it made me. It raised questions in my mind about Mike.
Okay, hold on. Whoa, hold on 1 second, dog. You've been hinging your whole thing like you had this secret argument, like we haven't repeated this. Or it hasn't been done again. Hold on 1 second. And you're actually not even contending the timing. You're talking about something completely irrelevant to the argument. What, dude, it's already over. GG.
I was just answering the question about what my position is. I'm sorry I went there, but I was asked what my position was. So I don't care
anymore. I don't care anymore. What specifically is your contention to the Blodgett Peak measurements?
Well, I don't know. I think that the timing is weird. I agree
what does that
with
mean?
Jesse. I think the time it doesn't agree with the globe. Is what it means.
He did it from the incorrect location. Jesse did it from Mike's house. All his measurements were off by 33 seconds or whatever.
Yeah, I agree with Jesse. I saw the same thing. Jesse, I only realized that Jesse had seen it too when he started
11:33 p.m. Alan, 11:33 p.m. Timestamp that for when you go back to your recording. He just said he thought that his timing measurements were funny, so he thinks that he's lying about the timing.
But he doesn't.
No, I don't.
He's not going to accuse him of it
that.
or whatever. But
I didn't say that.
Yeah. So anyway,
I didn't say that. But there is
okay.
something weird
So
in
at
that
least
data.
they know that they're cooked. At least they know that they're cooked if it works at multiple locations because their entire argument this entire time is hinged on this one observation just being a coincidence.
Yep. Yo, we're gonna wrap up. Yeah, we're gonna wrap up here. With that, thanks everyone for participating in the. Yeah, 1 second. Go ahead, Jesse. What's up?
Okay, so I did a test with a hypothetical mountain at 60 miles away and a delta height of 13,928 feet. And using the arctangent of the rise over the run, I get the same angle, the exact same angle that Pikes Peak does. But when I put the coordinates for that into Stellarium and turn off atmosphere, just like Dr. Heffron did on Pikes Peak, it gives 2 minutes 57, or 2 degrees 57 minutes. So I don't think.
What star did you use?
39 Aquarius.
He just said it's a hypothetical mountain, basically. So he can't go out.
Not only that, It's constructed in such a way that it's not analogous to the mountain that actually is getting measured. He's like changing the position and then saying, why doesn't it match? Which it's going to be different for different locations. The specific point of this, oh yeah, and then he tries to claim that that only works at Mike's house or whatever, based off of that not working symmetrically, even though in both models the prediction would be different. And this isn't a relevant or analogous comparison. And I went over that yesterday with you specifically, and then Beast also went over you, and the fact that you waited until like what is wrong with you? What do you think you're doing by asking a non-analogous question again? What is your purpose here to do this? Like, because here's the thing, boys, we are moving onward and upward with this. More people are going to start doing this, and you're not gonna you're just gonna fade away. What you just did is ridiculous, dude. You and Mike both do the same sorry, you and John do the exact same thing. It's so gross.
Wait, so this hypothetical mountain is Pikes Peak, but he's just making it bigger?
No, he's doing the thing he did yesterday with the bigger mountain that would be like same size, proportional, but distance, and then he's going off of the distance where it isn't being occluded that we calculated based on because the way that this works, right, is it's based off of your distance that you're calculating the object to. If there's another object that's further away, you're going to have a different calculation for that. That's not...
You'll have a different occlusion time.
Yeah,
you're supposed to use it an occlusion time, Jesse.
Yeah. So if you don't understand that part of it, then there's really nothing
with a hypothetical
further
mountain,
to
you
discuss.
can't measure a star.
Let him respond. So you're supposed to use an occlusion time, right, Jesse?
Right. So if the true geometric elevation angle, the slope to the mountain is the same, why would the occlusion time be different?
Did you measure this? Did you physically measure the occlusion time of this hypothetical mountain that doesn't exist?
No.
Oh wait. Okay. Okay. Cool. Well, his question doesn't have any validity to it if he doesn't have a measurement.
So are you?
Yeah.
saying...
Take another mountain peak and prove that it's not a coincidence, dude. That's all.
So. So are you saying that the light is curved up at 13,000 feet, and that
no one's saying that? People are saying go do this yourself.
Dude, that's preposterous. We're saying go do it yourself. I'm gonna outro out. Thanks for the questions or whatever. All right. So this is gonna be great. This is why this
Alan,
is so
real quick.
Go ahead.
Alan, real quick. It's gonna be great because the thing is there's a lot of experiments that are kind of difficult to do. The only thing that's required for this experiment is someone to download an app to identify a star and then record with a camera and take a timing. So we're going to have within this year, plenty of people doing this at different locations. Then watch, I predict that their position is going to change and they're going to somehow attempt to incorporate that. Oh, well, that's just the way it works everywhere on Earth and it would always look the same.
If you're a flat earther or a glober and you have the ability to record this, but you don't want to take the time to figure out your stellarium timing, send me an email of whereabouts you can do your observation point. Obviously, don't put your address if you're here. You don't put the distance or latitude, longitude that corresponds to your house if you happen to be able to see the mountain from your house. But if you have a westward facing house that you could look at, east facing west, there's a mountain that you could look at that's just send me the details and we'll work out something and see what measurements can be made. More people need to get involved in this on both sides. We need measurements from both people all over. So the more people that can get involved, the better. And like I said, the hardest part of this is basically just finding a star that happens to match. I will do that for you. Send me an email. If you can make more measurements happen, that we can record and upload, the measurements and the timing, so it's all time stamped and proper. That would I'll do it. I'll help you. All right, that's really all I want to close on. The significance of this is profound. Stellarium doesn't need to know where Mike's house is for this to line up. That is extremely significant of that. This is a mutually exclusive flat Earth prediction that is trying to be co-opted by misrepresentation and using apparent positions of things when the apparency is what is in question. And we're referencing the raw flat Earth planar physical elevation, like what it would be if it wasn't slanted away from us, and also the so-called true position of the star. And it just so happens that at the same time that those angles match up from 50.7 kilometers away or from 35.8 kilometers away, depending on your mountain, the stars get occluded at that same corresponding angle, showing that geometric object blocking it is physically at that calculated elevation for the flat Earth prediction.
Crazy that their whole position is that Dr. Mike Heffron is like a wizard, and he just luckily lives at the one location where it would look flat from his house for that mountain.
Wild.
No, he chose a star specifically for that, didn't he? He picked
Any star would
one.
any star would work at that occlusion.
No,
they would all
no.
occlude at the same point.
Yeah, he chose one where the angle of the
No, Dazza, no, he didn't choose one for the blah 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 blah. He did other ones at different locations, and we're trying to get more people involved to confirm the same. So if you can do some observations, that'd be super helpful instead of doing what you're doing.
Yeah, just bring something to the table to talk about. Be like, I did this at this location and saw this star, and then we can have a conversation, because this has been going on in circles.
Yep, we've reached the climax
I think
of it here. I'm going to roll my outro
actually
here.
measuring that.
Whew. All right, lads and ladettes, thanks for hanging in there. I know that was extremely strenuous and kind of hard to listen to at times. It was very stressful. But this argument is extremely important, and everyone can get involved in this observation. If you need help calculating where the star is going to be, reach out. My email address is AlanSpaceAudits@gmail.com. You can email me there. Send me your coordinates of the peak you're going to be observing, and if you can get about 20 to 30 kilometers away from it, or even maybe 15 kilometers to the east of it, let me know, and I will help you find a star so we can get some more of these measurements. See you guys tomorrow for Ether Roundtable. We will likely be doing an update to the Battle of the Beams. There was a channel called Drunking Debunk or Drunkard Debunk, something like that. The Drunk Debunk Show. Oh, I think it's called the Drunk Debunk Show. That's how it goes together. The Drunk Debunk Show. Go there, check out their Prezi. The guy's Prezi was actually had a lot of supplemental technical detail in there that I didn't include or know about, and irrespective of the fact that he's kind of like condescending a little bit and stuff. But the information though was awesome, and you should definitely check it out. And then we're going to be doing I'll be doing like a review, or not a review. I'll be doing like a rebuttal to the main points of the Prezi. Some of the stuff is like, non sequitur, not important, whatever. I'm just going to let those be. But the big main facts that, like the big argument that he puts forward, I'll address on Tuesday. And then we'll probably talk a little bit more about the celestial theodolite. And we really just want to get people more involved in this. So if you have, if you're interested in this, or let me know.